Does at least this part work? Does this at least work?
No. I mean, that's not the issue.
I know, but sorry.
Yeah. Let's fix the.
Did you test this yet?
Actually not. But,
Okay.
let's get the ticket working. Well, let's see.
Oh, good.
No, it actually works.
Plugging in the projector made that.
That's pretty random. Do you have our timing? Okay, if you can take care of the time.
You mean keep track of time?
No, that's what we're actually staying in because I gotta see our
Keep the agenda open. You're saying.
exactly. Okay, yes, we can get started. Okay, good morning everyone and welcome to the ICE working group. Note well applies. This is the IETF. You have seen this quite a few times already. Hope you have read it and also understood it. There's blue sheets going on. Please sign them. We have a volunteer JavaScribe and a note taker already. Thanks a lot, guys. And when do you speak? As usual, use the microphone and please state your name when you speak. On agenda today, we're now in the introduction part. Following this, we will have for IceViz as full 60 minutes, closing down the final open issues. After that, we have Colin's draft about how to do global pacing, TA, etc. That's one of the key open issues in the ICE work. Followed by that, we have Trickle ICE for 45 minutes, and finally, hopefully, we still have time for a proposals for a set of ICE improvements. Status of the working group, we have our first draft has gone through IETF last call, dual stack fairness. There's a set of security and gen area comments that still need to be addressed before it will be going to IESG review, but that one's progressing well. And IceViz and Trickle ICE are both on agenda. And of course, the key goal for meeting today is to really close down the final open issues on ICE, both Trickle and Viz, because those are the ones basically right now holding back some of the WebRTC work. So we have a bunch of dependencies in both WebRTC and eMusic groups. And the idea would be to close those final open issues, go for last calls, preferably as soon as possible. That would be maybe next month. So let's try to work on that. With that, Krister.
Right.
Yeah, that's right. Yes, yeah, 1 hour.
Okay, so I'm going to go through what's the status of the IceViz draft. First, I'm just going to go through the Buenos Aires decisions, the agreements that we made there, which have all been implemented now. So if you have read the latest version of the draft, those are all implemented. There were some other discussions and agreements on the mailing list since Buenos Aires also. I'm going to go through those. And then a few words, and I assume that's going to take most of the time today, is still to do. There are basically two things that we still have to do. One, I think it's mainly editorial, but the other one is a little more technical. There is a solution for how to do that also, but it may trigger some discussions. So one of the things we decided in Buenos Aires, which have now been removed, is the removal of aggressive nomination. So now the draft only talks about nomination. There may be some word somewhere talking about this was previously called something, but basically the draft only talks about nomination. And one thing which is important to note is that if you are an agent, you must be still prepared that the removed pair is still using aggressive nomination because it may be an RFC compliant endpoint. So you may receive all this stuff, but you must not. Yeah.
Clarifying question, and I might have missed that in 5245 bits. Let me leave off. now that we remove aggressive nomination and we say that agents should be prepared to receive media before ICE processing has completed, we do say that, right? It would probably be worth stating that at least one successful check must have taken place before agents try to send media. The reason I'm raising this, we were having a discussion with Boris yesterday, and basically, unless you have that, it is impossible to multiplex multiple sessions on a single port in a media server, for example, unless you've had a successful check first, so you got the UFRAC, so you know you can map the 5-tuple to a specific agent.
So Martin Thompson, there's a security requirement on that one. If you don't receive the check, you don't have the response to a check, you don't have consent to send. That's certainly in the consent doc. I don't know if it's in here. I remember it being sort of in 5245, but as with anyone, I mean, but it's a mystery as to how anything can be found in that document. So.
I don't remember exactly what it said, but could you take an action point to take a look at the BIS and see whether it's something needs to be done?
Yes. Ari Keränen, I think it says if it needs to be validated, the pair before you can use for media. It doesn't have to be nominated, and validation requires a full check.
Yeah, that's right.
So you think we're good, or you still want? Okay, thanks. Can we get that in the minutes so that Emil will check it? Yes. The other thing we decided was regarding keep alive. We removed the text about the no because that was not going to progress. We also removed the text about what non-ICE agents need to do. So now the drafts only talks about what if you're an ICE agent, how do you do the keep alive? The connectivity check pacing, previously there was a separation between real-time media and other traffic. We removed that, so now you have a single formula for calculating the TA and RTO, which changed the recommended value to 50 milliseconds, but it's important to remember that you can use other values if you have whatever protocol that doesn't really need that value. You can choose another value as long as it's bigger than the minimum value, which we agreed is 5 milliseconds.
So I think this is wrong and we need to fix it, but Colin Jennings, I think this is like, we're gonna have to change this, but let's just wait to the next presentation after my stuff and we can come back to this one and rethink it a bit, but I don't think that works. And I don't want to discuss it right now. I just want to flag, like, that's the essence of my presentation, is this doesn't work.
Just to be clear, I don't think you want to change the substance of this, just the Martin Thompson. I don't think you want to change the substance, just the numbers. Is that right? Just to make so we can agree on the rest of it. And the numbers are probably
numbers are a problem, and whether it's a global pace or a per ICE agent pace, right? Those are two things. And
yeah.
Well done. Yeah.
I should just clarify that this is per an ICE agent pace. Then we have a separate thing with the global pacing, which we are going to describe later, which may have. But this is basically the core stuff. If you have an entity and you only have one instance of your ICE agent, this is what you do.
Right, and I only have a problem with the values, not the structure of this. So that
But okay. you still have a problem with the values? I didn't hear what you said.
Yeah, 5 milliseconds won't work.
Oh, okay.
So Colin, can you clarify? So you're saying 5 milliseconds even with a single agent, the classic case?
I have slides on exactly walking through this. So all I'm suggesting is we come back to this one after my presentation. That's and we can rethink it then.
Okay.
Okay, so the other changes, like I said, this was not presented in Buenos Aires, but it was raised on the list. One other thing was we needed to clarify that if you do an ICE restart, you don't really by default renegotiate or redetermine, as the word that's used, the ICE roles. You keep the existing ICE roles. Unless there's a few cases where you actually have to do it. If you are changing the implementation role, for example, you were previously a full ICE and you were the controlling role. But if for whatever reason you change to ice light, some use cases have been presented when that could be done, then you're not allowed to be the controlling agent anymore. So you have to renegotiate and become the control. Also, if the ice restarts causes role conflicts, then obviously the roles need to or may end up be redetermined. I mean, you need to redetermine them, and you may end up having the same role as previously, or you may not, but still you need to negotiate them. And there were some certain, especially some certain third-party call control scenarios where this could happen. Then there were some general clarification of the tiebreaker concept. I don't think it was really clear what it really is, and so on. So, but that was mostly editorial. So this is one other thing. The other thing we did was we added a reference to the dual stack fairness draft and a little bit associated text with that. And thanks to Paul for doing the pull request for that one. It has been accepted that it's in the latest version of the draft. Still to do. I guess we don't want to talk too much about, this is, Colin, what you're going to talk about, so I won't say anything about it now, but just to point out that this is something that we still need to solve in one way or another. My suggestion is here that it should be a separate deliverable, but I know people have other opinions, but we come back to that. But then there's another thing which is a technical, no, this is actually something I had already in Buenos Aires, but we didn't have time to go through it. It's been suggested that we should remove this frozen candidate concept. And these are just claims. It doesn't seem to be widely implemented. It's not very usable for a low number of media streams, and bundle will take care of when you have a lot of media streams. And even if it's not in the specification, you could still do this as an implementation-specific, non-standardized optimization. There hasn't been too much support for this. And there's nothing which is broken today. I mean, this would just be, you know, make the ICE draft simpler. There's nothing broken today. So my suggestion is, let's just keep it as it is. Don't move it anywhere. Keep it. There may be some fixes that we have to do related to other things, but the frozen candidate concept as such, let's keep it.
So I'd favor keeping it, but what I'd say is if we're going to move it, I think we have to say you have to do bundle. If you're not doing bundle, like frozen makes a huge difference. And it's not like what you could, like when you say some people have not widely implemented, I mean, something that implements it won't interoperate with something that doesn't implement it because the timing of the checks gets so out of sync. So, you know, this is an either we say we require bundle and throw out frozen, or we leave it sort of like what it is. I can go down either of those paths, but.
Peter Thatcher, Google. I disagree about the value of frozen, but being one of the main proponents for removing it originally, my motivation for suggesting we remove it was mainly to make it easier to resolve the trickle ice freezing situation. But since we've resolved that with freezing, the motivation for removing it is less. So that's why my support for it's not so strong.
Good. So I guess unless someone really strongly want to remove it and have a good justification for that, we just keep it.
Okay, to just make it official, is there anyone who thinks we still should remove frozen? Please raise your hand and, well, come to the mic. So for the notes, we don't see anyone rushing for mic, so we will keep the frozen algorithm part of ISPs.
Okay, and this is then there's another. No, I don't know. Are not these the section numbers? I forgot to check whether these are the section numbers in the list, but that's maybe not important. The one problem which was raised was the unfreezing checklist programs. There are two sections, and which says that in the case of failing initial pair for a given foundation, all remaining pairs will remain frozen, which is the main purpose of frozen. You don't test those because since one doesn't work, the other ones with the same foundation are likely not to work either. However, I think Emil or someone found a text in another section which says that when you do the unfreezing, you actually unfreeze the whole checklist. not only the pairs with the same foundation, and which basically is not, which is kind of stupid. So the suggestion was just to remove the conflicting text from section 5.8, and we thought, that's all easy. But then I think it was Justin or Peter, someone found an issue, and I think I asked Emil to come up and explain this because it's easier to do.
Okay, so this will be significantly easier if we think about the whole freezing process in terms of this table here. I'm actually making the claim that we should probably adopt this representation in 5245 bits in order to explain the entire process, because right now it is very, very, very difficult to create an intuitive understanding of unfreezing, and it really is actually quite simple if you look at it from a table perspective. The idea of this table is that in columns you have foundations, and in the rows you have stream components. The way freezing works by default is that you start by unfreezing the entire first row, then you operate per foundations, which means that if any of the columns get a successful check, you unfreeze the next cell that's right underneath it until the entire first checklist succeeds, and then you unfreeze absolutely everything in that column. So again, if you think of it from a table perspective, you do entire row first, and then trickle down like the matrix thing as things succeed. So the issue that Christer talked about, is everyone on the same page so far? So the issue that Christer just mentioned, that I believe Justin raised first, was that if you unfreeze any candidate in the checklist, like for example, if you unfreeze this one, currently 5245 tells you unfreeze absolutely everything in that checklist, which entirely kills your freezing optimization. So we said we should remove that, but then what Peter said is, wait a second. If you have a foundation, like here, this column, for which candidates do not exist in the first rows, then you remove the thing that unfreezes entire checklist because it's sort of a bug. And because there was nothing here in the first row, the text in 5245 as it currently is would never unfreeze this foundation here because it was not represented in the upper rows. And again, actually, when you look at it from a table point of view like this, the solution is almost obvious. It suffices to say, rather than starting by unfreezing the entire first row, we change that slightly and say we unfreeze the topmost pair for every foundation, for every column, and then everything works.
Hey, Colin James, this may be a great idea. I'm still trying to get that through my head. But I think that those other pairs would have been unfrozen. There was text somewhere, if it didn't get deleted, that said, once your checklist was empty, once all the unfrozen things had been dealt with, you went and did the next things that were frozen. So all of those other things would have, in the classic algorithm, all those other things would have checked before the red ones checked, but they still would have checked.
So the thing with 5245 is that you're never certain that something is not there. And
well, you are certain when your list is empty and there's nothing else to check. And when that happens,
so currently the only text that I've been
thing.
able to find is the one that says if you unfreeze one candidate, you unfreeze everything, pretty much.
Okay, well, it should have something which says if the checklist is empty, then you unfreeze the next row that has no unfrozen candidates in it. I mean, that text should be there. We may have deleted it by accident, but that's how it's supposed to work. Now, your solution may be better. I'm not arguing.
So, Jonathan, so the problem is that, yes, it says that, but it says if the checklist for a row is empty, not the checklist for the whole session is empty. So basically, so you unfreeze, so the specific details of the bug as it is so you unfreeze, say, the video 192.168 address. Now, the video 1 checklist is now empty. So what 5245 says is now you start unfreezing other things in video 1, even though the other checklists are still running. Which is clearly not what we want. I think what we would want is if there are no, if all the checklists for the entire session are empty, yes, start unfreezing things. But that's not what it says. It says if the checklist for a particular component is empty, then you start unfreezing things. And that's the bug that means that Frozen is essentially broken. Now, maybe it meant to say that, you know, if the checklist for the entire session is empty, then you start unfreezing things. And that I think is reasonable. That's what it do. So let's, okay.
Well, some of them. I would actually make the claim that this is a separate thing with whether or not to, like, once you went through your entire checks, everything that you should have unfrozen, you unfroze, and you still have gaps, components that don't have candidates. At this point, Jonathan says, and Colin, you said that as well, there should be text that says, try everything else now, even though it was never unfrozen. I would argue that this should be an implementation decision because it's basically a choice between whether I want to be able to tell my user that this is not likely to work quickly, or whether I want to wait 5 minutes on the off chance that maybe something would work.
Well, I mean, it's always, Jonathan, nice again, it's always an implementation decision to give up at any time. Any implementation can do that. Yeah. So, I mean, you know, I think.
True,
Yeah.
but maybe it would be good to not label such implementations as ICE incompatible because they wouldn't break anything else.
No, yeah, and I'm saying, yeah, I agree. But the point is that your choices are keep doing the algorithm as we specified, or, you know, signal, you know, what in some however way you're saying, you know, never mind, I'm tearing down this call. It's
Sure,
not just sit there and wait and don't do anything else.
Yeah, a bunch of ours just if they don't get connectivity in 3 seconds, they just say sorry, no connectivity. But I want to come back to the actual idea. First of all, this table, the way you're representing this is the most clear way I've seen yet. Great, thank you.
That was actually Martin's idea from 3 years ago.
From this very good way.
It was actually Boston in a snowstorm, but
So
where I heard it.
But on the actual idea of unfreezing the highest, the top thing, the top, I don't know.
Yeah.
Instead of unfreezing column 1 to start with, unfreeze the sort of the
Yeah.
top surface there. I don't really think that really achieves what we want as the optimal approach. I mean, our meta goal here, if you think about it, is let's take just one of our streams, like audio 1, and figure out how we can get connectivity on it. And once we have connectivity on it, then try and use that same connectivity approach that worked for it for our other media flows. So I don't think we really want to start checking video 1 and video 1 at the beginning. We want to just start with audio 1. What's really weird about this use case is that video 1 has connectivity paths that audio 1 doesn't have.
Sure.
Right? So I agree we need to check them eventually and we need to solve this bug somehow, but I'm not sure we'd want to start checking video 1 right away as sort of an optimal strategy for getting to an answer quickly.
Jonathan, so really, I mean, really the case that I'm concerned about here is not this, which I agree is weird, but actually where audio 1 and video 1 actually have entirely non-overlapping foundations. This is distributed media. That's very realistic. Yeah, so, and that is the case that I'm actually concerned about, where I don't want to, if you have non-overlapping foundations, I want to start all the non-overlapping foundations simultaneously.
All right. So we agree that the same rule solves both the weird case and the more common case.
So that suggests then that Martin Thompson, I apologize.
For being Martin Thompson?
Yes. That suggests that the solution is correct for the case that Jonathan identified, and has the consequence in the case that Floppy identified, that if you have extra pairs, extra foundations on a particular component that is further down the priority list, then you're going to be doing some checks on that ahead of time, and maybe that's suboptimal because maybe it's.
But it's a corner case.
But it's a corner case, and it's not a big deal. The reason I sort of waited a while for this is I don't understand how you intend to make this work with Trickle, where you have holes in the table at
So
various
with
points.
Trickle, and actually I have a slide about this, but we might as well have it while we're looking at the
Well,
table.
the table will help.
Yeah. So with Trickle, the idea is that you keep the same rule.
Yeah.
Wherever you have, you always unfreeze the first thing in every column. If something arrives that logically belongs before that first thing, you also unfreeze it.
So,
If
if you have this situation here,
Yeah.
and it's just that Foundation 4 on audio is being trickled and
Yes.
hasn't arrived yet,
Yes.
when that arrives, you unfreeze that automatically?
Yes.
Is that the suggestion?
Yes, you start by unfreezing whatever you got. If
Yep.
something arrives after that and it belongs here, then you unfreeze it automatically.
Does that create a pathological case where you receive trickling from the bottom up and you've unfrozen everything?
Yeah, it does.
It does?
Yeah.
Is there any technique that you would recommend for avoiding that particular scenario?
I don't think that it's worth the hassle.
Jonathan says trickle in order. We're done. Okay, yeah. I think that's actually really, maybe we should write that down.
How do you say that?
Yeah, we do recommend that we should be, but then you should account for cases where you have desequencement in the trickling of candidates.
Yeah, so we don't necessarily need to require that everything be strictly ordered delivery or anything like that, because that's just,
Yeah, we currently recommend that you
Same.
should trickle in order of stuff.
yeah, but we should certainly recommend that you at least try. And if there's some
Yeah.
reordering in the network, then, and what have you, then that's
Yes,
you'll get some extra unfreezing, but it's not going to be yeah. You're unlikely to end up in the pathological case. And I think-
Can we have the note taker have an action item for clear recommendation or trickling on trying to trickle in order of I don't want to say SDP, but declarative order. Yeah, if you could just write it down that way, I'll remember what we meant.
Tim Panton, for the ignorant, there's an implied ordering vertically, which I think it would be good to say what it is in that table.
So
We've been talking for 5 minutes and we haven't said what that axis is.
So a checklist generally corresponds to a media stream. So the order here is basically the order that you see in SDP in general, which is first streams first, and within streams RTP first, RTCP second.
Generally, I mean, I think I would sort of generalize that to say is whatever the IC using protocol is has to define what the order of the streams is. For SDP, it's the order they appear in the SDP.
Yeah.
For something else, it's
That's it. Yeah.
it's whatever, however you define it, make sure but you have to define it.
So Colin here. I mean, so I'm convinced by Jonathan's argument that the use case, that what I was describing we need to optimize for was the wrong thing to optimize for, and what you're proposing is a good solution to this problem.
Okay. Thanks.
Okay, before we go further on this, so we had a discussion that this table thing is a very useful thing to have. Should we have it in ICBIS appendix or somewhere?
Martin Thompson, this is largely editorial, as Jonathan mentioned here, but I think having an example, if we have examples and actually showing how that progresses through, and drawing up the table of the various pairs, and then having numbers next to them showing the order in which they're unfrozen and the phases in which they're unfrozen, sort of explaining that you go across the first line and then so on and so forth, and maybe even including this exact example would be good as well.
Okay, so Cohen is asking for animated ASCII art for this thing, which I agree is good. There's actually a little bit more than a slightly editorial change, because there's two questions. First of all, do we want that as an example, which I think is probably pretty consensual, and I'm volunteering to provide the example. The second question is, do we want to think about rewriting the current definition to be over the table and use the table as a defining support for the specification of the protocol? Or with the idea that would make it simpler for everyone to implement? Or do we think that things are good enough and we only need an example? I think that's the underlying question.
I guess the question is, do we want the table to be a normative part of the
Colin James. Normally I'd make jokes about it was hard to implement, so it should be hard to understand, and that we should change that. But we're so close to done at this point, that'd be a really major surgery on the doc. So.
Yeah.
And we need the third thing, which is we're actually changing the algorithm to unfreeze differently, right?
But I understood Emil is willing to create a pull request, at least for that part. No, for the change in the.
Oh, that too,
But you can do both. Don't worry. I mean, you. So you're willing to also provide an example?
Yeah.
Excellent.
Okay, and can we have those before the end of month so we can consider last calling next month?
Before mid-August.
Okay, first week of August. Thanks, Emil. First week of August.
Okay, I think that's all I had because the rest were just describing the problem. Yeah, this just came here to look for Pokemons. There is an ice type for you. So.
Oh, you gonna do that?
That's all I had. I guess Colin will come up with a.
Yeah.
I don't know if we need to come back to these slides because what we need is an agreement regarding this pacing and then I guess the Buenos Aires agreement regarding the timer values or at least the minimum value. We have to make sure we get some kind of outcome, either that more discussion is needed or that we actually make a new decision. But I guess
That's coming up in the next thing. But before we go there, it was brought up that we might want to add text that makes it so that when you've checked everything that's in the whole session that's frozen, then you begin unfreezing things. So there's no text in there now that does that, but it sounds like we want to add text.
Yeah, Jonathan, I'd say we want to change the text that currently says if there's something in the checklist that's unfrozen, we want to change that to if there's something in the whole session that's unfrozen. But we'll
I
work.
think it's a bug if you don't fix that. It doesn't
Right.
work, right?
Yeah, right,
I mean,
okay.
it's good.
But we want to go to working group last call next month, so we need to decide
Okay, yeah.
if we're going to do that or
Well,
not.
we'll try to do some wordsmithing on that after. I mean, I think we have consensus that that's a good idea. We need to I would say we just need to wordsmith it, but.
Oh, okay, so do we,
not think that's a good idea?
right.
We need two things though. We need that is a change in the text, right? And the other change in the algorithm is what Emil's proposed, that you're not going to unfreeze just the first row. You're
Right.
the highest thing in each
Yes,
row,
I
right?
believe we have consensus on the covering the surface. And now the question is, do we have consensus on unfreezing things if everything in the whole session that was unfrozen has been checked?
Anybody object to that?
Anybody what?
Anybody object?
And then if as long as we don't sort of make it sound as if not doing that is breaking ice, then I'm fine. Because again, I want to be able not to do that, and because I want.
I mean,
want,
do you
like-
want to not do that? I mean, if your choice is, do you want a choice other than do that or give up? Do you want to?
Yeah, I want to give up.
Okay, giving up is fine. You can give up at any time.
So I want that to be clear.
Okay, yeah. No, I mean, I think that's fine. I mean, at any time you can,
Separate things.
and where give up means tear down the call and do whatever signaling your protocol says for tear down the call. I mean, that obviously you can do whenever. I mean, you can pick up the call, try to call somebody, and then hang up, right? So that's always allowed. You don't ever have to keep doing ICE if you just abandon the call. And you can abandon the call for any reason you feel like abandoning the call.
Let's take the next time. There's clear text in there. You can quit at any time.
Okay. Say that clearly.
So Colin, so let's resolve. I think there's consensus for what Jonathan proposed of how the check works, and I'm saying I think there's also consensus that and we should put into the draft clear text that says you can quit at any time.
Right? But you must do whatever signaling your protocol says to tear down the call. Yeah.
Okay. Did the note taker manage to capture that all?
Mark.
Oh yeah, Mark got this, no problem. He actually wrote what we meant to say and has fixed the algorithm. You guys are all nuts. I'm putting the real thing. Okay.
Yeah, he wrote the pull request while you were.
Yeah, Martin Thompson, I just need to make sure that when we talk about starting to unfreeze things, we don't end up in a situation where we're unfreezing things that we didn't want to check in the first place. So you imagine the situation where you have some components that are actually connected. There's a possibility that some of the pairs on that component will be frozen still when you reach the point where you run out of things to check. If they're already connected, there's not a lot of value in actually.
Only if they're priority, right?
Yeah, yeah,
And once you got something with better priority, you should throw out everything.
Yeah, well, I mean, I think,
right. And so I think there's potentially a little tweak to be had to this that says components with frozen candidates that are lower priority than a successful pair can be simply marked as give up rather than unfrozen.
that's not even possible, actually.
Yeah.
Emil, the high priority would have been checked first anyway. So there's no way you can end up with a situation where you have a
Yes, there is. Jonathan, yes, there is, because if this is not the first component, and something succeeded so something triggered an unfreeze of the column in the first component. So I mean, Jonathan, I mean, I think what that actually says is what the spec actually says is you move things from frozen state to waiting state. So maybe we should have something that says, like once you've, nominated if it doesn't already say this, once you've nominated something on a thing, everything else goes from waiting to, everything that's still in frozen or potentially waiting goes to failed. Well, no, it's yeah, I think it's once you've nominated something, everything that has not yet been checked goes to failed or whatever. No.
So Martin Thompson, I think the right way to do this is when something comes out of waiting and you're about to start sending a check that there's something on the component that's higher priority and connected, in which case you can just simply abandon that pair. No.
Can you go back to
Why not?
Because priority order is not necessarily actually the same thing. The whole reason why we have regular nomination is because highest priority is not necessarily the thing that the controlling endpoint actually wants to use. So controlling, the whole point of we have regular nomination, not aggressive nomination, is that highest priority is not necessarily the thing that the controlling endpoint will nominate. Yeah. So, I mean, that's why I'm saying once something is nominated, then you can stop. Then you can move things from frozen and waiting to failed.
yeah, so we need that.
if we're checking Emil, should we be concerned about the order? Because we could, like, if we paste them, if we imagine have a bunch of things that haven't been checked, and with paste and everything, you could still end up in a misordered situation that makes you use an ordered checklist to begin with. Am I making sense?
Possibly, but I don't think designing it at the mic is a good idea. Let's meet over lunch or something.
We're doing it. It's so much fun.
Yes, I understand. The other question I had, because I got here late, I was looking at the slides. You're thinking about changing how roles work for ICE restart. I want to make sure that that will actually work correctly with a 5245 endpoint doing ICE restart, where it assumes, roles do change.
Well, hold on. Before we move on to that, let's make sure we have
Okay, sorry.
conclusion on the previous topic. So we're walking away with consensus that when everything is checked, we start unfreezing everything. And then
we need to make sure we understand what order you unfreeze everything, and we're going to figure that out later.
This week?
Over lunch?
Yeah.
Okay.
And Emil wants to make sure that it's clear that we can quit at any time.
Yes.
Okay. So that's
So I was saying, I was looking at the slides for what was talked about before I got here because I overslept. Sorry. Before it was, yeah.
so.
One, yeah.
In response to your question, I think that as long as the 5245 endpoint implements the conflict resolution properly.
Okay,
then
so
you're
it'll just be conflict resolution every time and deal with it.
Yeah.
Okay.
Yeah,
Now,
I think
now, if
there
it
is,
doesn't, then you would have a problem.
well, I think there is text talking about, again, if you're communicating with a 5245 endpoint, it may try to renegotiate the. I don't remember exactly what the text says, but there's something like that. So maybe you should take a look at that. So,
An action to clarify.
Take an action to clarify that part.
Yeah, but I think it's there. But yeah, we'll figure it out.
Has everyone signed the blue sheet? Okay.
Okay, so at the last IETF, people asked me to do some timing tests on checking about this 5 millisecond timing. We had a few concerns about this. So have many people had a chance to read this draft? Show hands up. Okay. 4 or 5, perfect. Some of the details in this draft are wrong, I apologize, but like the size of some of the things was based off of what browsers were actually sending. There's a bunch of captures versus probably what they should be sending. So there's a few things that are off in it, but we could update it. But the slides have been updated, I think, to have correct numbers here. We had 2 concerns back then. One was about how, as we accelerated the rates of which we were doing these checks, what impact would that have on NATs, and could NATs keep up with it? And the other one was about the bandwidth usage, as that went up as well. So I ran tests on the highest end, newest, fastest, zoomiest NATs I could get from these 4 vendors. These 4 vendors represent a fairly substantial amount of the market share of the home residential NATs. And you know, some of the results that we got in there is like these NATs are amazingly compliant with many of the Behave IETF specifications and things like that. And it just highlights that what the results we got from these NATs certainly don't represent what's widely deployed in the wild right now. But I think they do represent what's coming over the next 5 years. That's why I sort of chose those. And on the mappings, there's really good news. We mostly saw mapping speeds of over 1,000 mappings per second and less than 10,000. So that's like a 1 millisecond type rate. This suggests that we really shouldn't be too worried about the 5 millisecond for this grade of NATs. And we got source code from one of the NAT vendors to be able to see why is this accelerated so much over the years. And really the bottom line answer is actually the code's a bit slower than it used to be, but we've gone from running on 30 megahertz MIPS processors to running on 1.2 gigahertz, Intel chips on these things. They're just much faster. Thanks. So I don't have any good numbers for you on, well, what's really deployed today and how would that really work, but I think that we can take a thing that even if the stuff that's widely deployed today is half the speed or quarter of the speed of what we have, we're still probably in reasonably good shape. The bandwidth stuff led to a very different sort of conclusion and discussion. That's the most important thing for us to talk about today. So first of all, I want to talk about sort of an evil case, which completely can happen, and we need to be able to deal with this case. It's going to happen in a WebRTC context, and there's variants of it in gateway context and other things. It happens probably most things that use ICE. So if you create 100 peer connections in parallel and tell them to all go do a bunch of sun checks at the same time, without some global pace limiting or global rate limiting, I mean, it's a disaster, right? That's not hard to figure out. So a lot of bandwidth gets used up at some point. And the obvious conclusion of this is we need some type of global pacing or global limit on how quickly we can send these things and how they get discarded. So what the browsers are implementing right now is, or have implemented, and I'm a little bit vague on the status of everything, is a 250 kilobit per second limit on across all the tabs in the browser, all the PCs in any given tab. It's sort of global for the browser limit on this.
Carry on.
Okay, of about 250 kilobits per second. Okay, and I'm not here to argue about whether that number is right, wrong, or whatever. Okay, that's like one of the things that we probably need to dig into somewhat is what is the right number. But what we need in the ICE spec is we definitely need some way of saying, of recommending a limit. I think, and I'll talk about recommendations later, but we need some limit now. Now, once you have this limit, there's some implications of this that then cause problems. So this is my next slide. So this is not an evil case. This is a very normal case where we've got a single peer connection, 72 pairs to check, actually quite low. That's like 2 interfaces, like a Wi-Fi and a cellular interface with V4 and V6 and a small number of things. You instantly end up at 72. a lot of our stuff where we have a lot more interfaces and a lot more voice and video streams is much higher than this. So if you take that and use this TA timing of 5 milliseconds, you generate about 480 kilobits per second. Okay, and that's that's one of them. Doing a simple thing, not a hard case. Right? This is about as low as the number really gets in a practical deployment. And if we're rate limiting at 250 kilobits per second, that means half our stun checks are just going to get discarded, and we're going to get like false negatives effectively in the ICE connectivity checks. With a TA of 25 milliseconds, it's about 180 kilobits per second. And look, this stuff is a little, it's not just a linear scale, because what happens is, the initial transmissions of one step check are already, the retransmissions of that are happening and overlapping with the initial transactions of other things. So you need to do a bit of a simulation. And this is bandwidth only for requests. I'm assuming there's no responses, that it just all fails, okay? So that suggests here that there is no imaginable case under which 5 milliseconds can possibly work. Well, if you let your bandwidth go to a megabit, right?
Martin Thompson, if you assume that we're in some magical, mystical world in which everyone has a megabit, then yeah, that's possible. But we're not there yet.
Yeah. So I think yeah. So that gets to it. It's a fair point. Martin's right. It's like, look, this the rate limit that we decide back here directly impacts what the minimum possible pacings are here, right?
Peter Thatcher. So I have a question. You have 72 pairs, and you ping them at 5 milliseconds each. So you're done with all of them after 360, right? Milliseconds. You send one check for each pair.
But you'd be done starting them all after 360, and then their retransmission timeouts would take however much longer. So they go quite a bit longer.
Right. So could we do something around that where retransmissions are treated differently?
Well, I mean, they still take up just as much bandwidth. So like, I mean, the problem is congestion on the link. Like right now, if you set this up as an example, and in the draft, there's a little HTML script. Right?
What I'm saying is, like, if non-retransmissions were prioritized over retransmissions, and even if you had multiple PCs, you can fit in quite a few initial transmissions on all the PCs before the retransmissions start getting hammered. Does that make sense? So if you're going to drop packets, if you drop the retransmissions before you drop the non-retransmissions, then you could. Oh, really? Can you explain?
I'm not sure. I'm sort of pondering this idea. It's not obvious to me.
So Martin Thompson, I think that Peter's suggesting we sort of let the new checks sort of push aside the retransmissions. I actually think that that's more likely to be a problem. I think in a lot of cases, when you're driving pinholes through things, you actually rely on the second check, not the first one working. So, well, you are the other side in a lot of cases.
Okay, because my co-chair is over there, can I do a quick, after Emil, I can go to the mic line.
Okay. So 2 points that I want to make. First of all, the way that pacing is currently described in ICE does not take
the RFC or the BIS. Because BIS
both.
broke it in my mind, right?
Both.
But, okay.
I'm not talking about the timing actually, but the way that pacing is defined is how it should be implemented. Does not even take into account retransmissions. It paces transactions. So actually, retransmissions would lead this to even a higher.
These numbers take into account that type of. These numbers are based on the starting each transaction happened at 5 or 25 milliseconds, and then the retransmissions were set at the first retransmission 100 milliseconds exponential back
Right.
to 50.
Okay, and they're not paced.
They're not paced.
Okay.
Yeah.
The second point that I wanted to make is I understand that this can be a problem if we put it in browsers, but then we're talking about the minimum requirement, which should be, in my opinion, you should never ever go below that, because there's not a chance in hell that this wouldn't break things. So it sounds to me that this is more of a case for recommended default value to be higher than the minimum value in the RFC.
I suspect when this lands with the transport area directors at IETF, they're going to be looking at what the amount of uncongestion controlled bandwidth that we end up using in a bad case. And they're going to have some thoughts about what would be an acceptable value of that. I don't claim to know what those are, but you know, we've gotten away with a fair amount of uncongestion controlled bandwidth in the past.
So clarifying question. Your proposal is that the bitrate limit, the global bitrate limit would include retransmissions, right?
Yes, yes, it has to, yeah.
Yeah. So a comment on that. Currently, the RTO is defined in a way that it would be the retransmission shouldn't overlap with the initial checks, but it should be a nice continuous train. Because the RTO formula includes the amount of streams you have. So you will be actually pushing out your first retransmissions after you have done the initial checks roughly.
Really? You could be right, but my
That's- that's-
implementation does, the implementations I've been looking at don't do that. That
Yeah.
may be what the spec says.
Okay, there's even a nice picture in the appendix on that. Try.
I don't believe, I mean, I'll tell you as a fact, having looked at the packets coming out of Chrome and Firefox, they don't currently do that.
That I don't have a doubt of, yes. But it's in the 5045, the RTO formula takes into account the amount of media streams you have just in order to avoid the issue that you would do retransmissions while you're still doing your first round of checks.
Ben Schwartz, Google. I'm just trying to understand your example. You mentioned this case of where there are 72 pairs. It sounds like there were 2 or 3 different network interfaces live or potentially live in that example. So what's your mental model of sort of where the bottleneck is in this system?
So I can explain what that example is. The 72 came from 36 come from IPv4 and 36 came from V6. Okay, and they get paired with each other. That's why 72 versus pairwise. I think it's in the draft, but I believe it was 2 interfaces. You know, perhaps a wired and a Wi-Fi, or we often end up with 2 interfaces, cellular, Wi-Fi, and then the local, IP address of your NAT that you got from Stun, and the relay address for each one of those. And I think that just that case you come up with about that. Now, and asking about the bottleneck, there's a bunch of things we can do to actually improve this, 480 kilobit number substantially. Okay. One is the shaved ice work, right? Making each packet smaller. The number of retransmissions we're doing is shockingly high. Like, I mean, we're doing like whatever, it's 7 retransmissions or something. I mean, if you need more than 3 or 4 retransmissions to get through this area, like you're not going to have a real great media experience anyway if your loss rate's like that. So I wondered whether we should talk about, reducing the number of retransmissions. And then, there's the pacing issue. Let me just jump into a second here of a straw man proposal. I think that ICE needs to set a baseline requirement of max uncongestion controlled bandwidth that a device can use on the network. And perhaps there's specific usages that may override it for various reasons, but we need something here. And I view it as unlikely we'll get past ISG without that. Then there's the issue, okay, coming back to this issue here of how many, let's say you use 5 milliseconds. Let's say we have enough bandwidth to do whatever time, one pure connection at 10 milliseconds. I'm okay with us just saying, well, our minimum value is 10 milliseconds or whatever there's bandwidth to support. And if you're doing 10 pure connections, you obviously have to back off a lot from that. And so Peter and I talked about some maybe clever ideas to try and automatically have the browser be able to figure out what the time, as more pure connections got created, you slowed them down and had slower timing so they didn't interfere with each other and the application developer didn't need to think about it. That's one thing we could do. Another thing we could do is just dump the problem on the application developer and say, look, if you're doing more than one pure connection in parallel, like you need to set your TAs to be different and let the application developer have to think about this. I think we could get away with publishing IceBiz without resolving that problem, just flagging the issue and saying, if implementations want to do something clever to control this for the application developer, they can, or the application developer has to take care of it themselves. I think we do need to flag. I mean, we have an application that sets up, I'll give the slight background. We're trying to fake out simulcast. We actually wish we had simulcast, but instead we're creating a bunch of peer connections. And we were doing those all in parallel because, like, why not, right? It's JavaScript. Async rules the world. And it's become more apparent why we were having bugs with that now, and weirdness is this issue. So I think probably this is a WebRTC issue, but we should probably advise people, like, look, if you're creating things, you probably shouldn't create things in parallel. You should probably create the important thing first and then go deal with your other stuff. We may, so basically, on the first point, I'm suggesting we make a change to IceBiz. The second, and that we map the timings up for that. The second point, I'm suggesting we document this issue and suggest up to all the people that depend on it, you know, beware, basically, right? The third point is maybe we already have this. I thought we'd agreed to do it, but I couldn't find it in the drafts. But in the SDP for ICE, trickle or otherwise, we have a way to signal the min TA that both sides are using so that we can line up the pacing so these things happen at the same time, and then continue on a way to make ICE smaller. So comments on this as a sort of rough plan forward?
Peter Thatcher. So just a clarifying question first. When you say add back to IceBiz, what are we adding back? There was no bitrate limit before.
The ICE draft, the pacing was all in the original ICE was always a global limit. Okay, it was not a per ICE agent.
So you're saying we're adding back the concept of global limit.
A global pacing limit.
But the novel part is that it's a bitrate based one.
I think there's two parts of it. The problem is the bitrate limit is a discuss this two different things. I think we have to have the bitrate limit as a global limit that's just hard. And when you exceed that limit, things don't get queued, they get dropped, right? Which causes failures. I think we probably need notifications or some way in the stats on WebRTC, we need to be able to discover the number of dropped packets, ICE dropped packets.
But that's not for this working group.
Not for this working group. We need that stuff. But we also need to figure out whether the pacing of starting new checks that we use to control its TA value is a global pacing or a per ICE agent pacing. I'm suggesting a global pacing, but we can go with a per ICE agent pacing too. It just changes how we think about the values. In the what's causing problems for us, a global pacing works better.
Right. So as far as what my opinions is, I like the idea of adding the concept of a global limit to IceBiz. I'm not convinced we need a number in IceBiz. I'm willing to hear a discussion about what other people think about that. A bandwidth one. Yeah. I like the idea of a bandwidth based one. I'm just not sure if the number belongs in IceBiz or other documents. I'm willing to hear opinions on that. I like the idea that you let different usages pick different recommendations for dealing with the concurrent ICE thing. You know, personally, I think after 5245 biz is done, we could look into the prioritizing different first ping versus second ping, but we don't have to design that now. And then the last point I think is a good idea too, but again, it doesn't need to block 5245 biz.
Yeah, of course, yeah.
Tim Panton, I'm just want to question whether bandwidth is really the issue or whether packet count is as vicious. I mean, some of the Wi-Fi networks I'm seeing, like the bandwidth isn't the problem, it's the quantity of packets.
I agree with you on the faster Wi-Fi networks are definitely, packet rate becomes a very relevant issue. I think that what I was thinking of, just as my personal thoughts on this when I was trying to figure out what we should do, the use case that was compelling to me as a use case we wanted this to work on and was most likely to be the lowest bar was sort of semi-crappy 3G cellular connections. And those tend to definitely be bit rate limited more than packet limited at these packet sizes and rates we're doing. That's how I thought about it. It may be wrong. Somebody may have a different example.
Ben Schwartz, what are your thoughts on a global limit versus either a limit per local interface or maybe divided by the minimum of the number of known local and remote interface apparent interfaces, or maybe somehow per interface based on the known characteristics of the interface, things like that.
Yeah, so I mean, I tried to think about that, but if we knew something about the characteristics of the interface, I think that we could do better, but I think that's very hard to discover. And the worst problem of this is a really relevant use case that happens all the time now is I've got incredibly high-speed Wi-Fi from my smartphone to the 3G hotspot in my pocket. And so though my interface on my local computer may be good, the constrained link is 1 or 2 hops away. And that makes it real, so that makes it hard to know the properties of the link you're on. The getting anything at the OS level, things the OS into the application is also hard, of course. And I thought about just saying, well, let's make this 250 or whatever the bitrate limit is per interface. But on so many modern machines, there's multiple interfaces running over the same physical piece of wire when you get right down to it. It just like the more I thought about it, the more I couldn't figure out what to do.
John Lennox, yeah, I mean, sort of to amplify that, I mean, it's usually pretty easy to figure out whether it's, 2 addresses of the same virtual interface, particularly v4 and v6, but I mean, it's quite common. Obviously, your VPN is going to be going over one of your real interfaces, but it looks like a separate interface as far as the operating system API is concerned. So, I agree. I don't think per interface is too hard if you're not the kernel, and ICE is never the kernel.
Yeah, Martin Thompson, I ran through the same thought process myself. We may find that in future this baseline can be increased, and we also may find that in the future we might be able to fit more into that limit. But I can't see anything other than this. You can't suggest to an implementation that they just wait when they're told to start the ICE agent, because they're coordinating with someone else, and it's really difficult. So this is it. I don't think we should do shaved ice before we do anything here, but I think it would definitely needs
But
to
I'm
be
not suggesting
in
waiting
ICE.
for shaved ice at all. That's a
Yeah,
completely
please.
independent thing, and is why I specified it in kilobits instead of ice packets, right?
Yeah.
Because then it doubles effectively when we do shaved ice.
And to Tim's point, yes, packets are a problem, but we're not actually talking about a packet rate that bothers me in this situation. Things on path should be able to handle a packet every 5 milliseconds, and we're actually talking about much higher, much longer duration than that. So,
Yeah. And Tim, I'm happy to rerun the simulations and count the max packets per second as well as max bandwidth,
It's not
just
that
to
many.
check it. But I don't think it'll be a
Yeah.
problem. Yeah.
Ari Keränen, on the third point, so ICP SDP already has the parameter to say, okay, this is my TA, this is your TA, and you'll use the bigger out of the 2. I guess that solves the third bullet already. Or is that something different?
This one right there?
Yes.
So is that in the, like that goes in the SDP right now?
Yes. No, that's in ICP SDP. I mean, 5245 bis says there needs to be a mechanism in the signaling, right?
Right.
That's all. And it says this, okay, both endpoints tell what they would like to use, and you use the higher out of the 2. ICP SDP actually defines the SDP parameter for this.
Awesome. I just missed it when I read. I love it when we are so fast. We've already implemented this bullet point. But yeah, that's all I want. Nothing else.
Okay.
Yeah.
Thanks.
So back to Peter's question about whether we needed to pick a number in this draft that could be overridden by other particular usages, but have something here versus just saying there needs to be a limit, but not specifying a number. Does anyone want to comment on that topic? I mean,
Emil, we already have 2 numbers in the draft. One is recommended and the other one is minimum. Based on what we're discussing here, it sounds like minimum is not something that we can set in 5245. And recommended basically means, if you don't know anything about your interfaces, you want to be on the safe side, then you should do this. And we already have 50 milliseconds there. So we might keep that as the only number. and then define a minimum
Okay.
in other
I was
specifications.
talking about a slightly different number. I was talking about the 250 kilobits per second.
Yeah,
So
so
I
that's
think we
another
need-
comment
yeah,
that I wanted to
right.
make. Even if we adopt bitrate as some sort of a metric that controls pacing, I think it's important to abstract that before the pacing timeout. And I think that ICE agents should still, the entire pacing should still be controlled by a pacing timeout, right? You shouldn't be constantly counting your bandwidth. We agree on that, right?
Let me, so agree with you. They're two completely independent things. I wasn't proposing linking that the bandwidth somehow set the pacing, other than in the draft logically how you could use. So we have the pacing TA numbers. They are whatever they are. But what I'm suggesting is at the very bottom of every ICE implementation, there's, a rate queue that is watching the total bandwidth of stun packets being sent, including retransmissions and everything. And if I'm going to use 250 just as a concrete number, if 250 is exceeded, it drops that stun packet. That's my proposal, and I think that I think implementations, regardless of whether it's in the specs or not, I think implementations have to do that to not have this huge denial of service attack capability, right? If the browser, or a gateway, or a phone with soft phone control, or just about everything else that uses SDP.
Ben Schwartz, Google. So to state the obvious then, why not feed that back into the TA calculation if it looks like you're going to hit the limit, and to expand that, it seems like with a little bit of arithmetic you could probably figure that out, but the arithmetic is not trivial. Maybe it would be useful to have that in the draft.
Peter Thatcher, the packet sizes aren't static. It's like they're different depending on the size of the UFrag, which is controlled by the SDP.
So what I would say is, I think we could do that at some level. And I think implementations could do that. I'm not sure that we need to specify it. I mean, we could suggest that implementations might want to do that without describing how. But what we need from a specification level is to say, this tool is going to be capable of killing networks that are this tall, but if they're taller than this, they'll be safe. I mean, that's really what we're getting at. That's what we need in the spec here, is what dies.
So Martin Thompson, I think having the min TA negotiated in SDP is a good way to allow implementations to make that choice. That's why I'm quite supportive of that notion. I think there's challenges in doing so. If you look at the way that WebRTC works, there's this gap between the point where you do the negotiation and where you actually start the ICE agent. And that can be problematic because you can find that you do negotiation for several peer connections and then synchronize the setting of descriptions on them. And that you may have been generating these peer connections with sort of the notion in mind that there was only one of them. But then when it comes to actually starting them all, they're all starting at once, and you've negotiated a TA of 5, which is perhaps a little bit low, but you've negotiated 5, and now you're suddenly starting 10 of these at once. That's going to be a bad experience for the people doing that, and we need to have a little bit of advice in here on simply, if you have multiple concurrent ICE agents, it may hurt. Don't do that. And the simplest thing that we could probably recommend is allow one ICE agent to complete its processing before starting the next one would be the easiest, the simplest possible thing to do. And then people who are smarter than that can work out how to sort of fit them into the gaps as necessary, and we can build the heuristics and all sorts of other wonderful things. But we don't need to write any of that down in these specs because we really just don't understand it well enough.
The other thing too is I've become very cynical about the difference between the min and the recommended. Why would you ever use anything other than the min? That's nuts. And that's what everyone does. They use the min. I don't even know why we have 2 different numbers in the draft, right? I mean, it should basically be min or something larger than that if you feel like it, right?
No, I mean, no. Right now, neither of the browsers use the min, and we don't plan to, because it's too low. It goes over the bit rate.
Yeah.
He's saying, he's saying you would always use the min. And I'm saying, no, you
So
wouldn't use
everybody used the min of the previous RFC. The fact that the min is wrong in the current draft, yes, I understand that, and that's why no, it's not usable. But
No, it's not usable in certain situations, but in other situations it is.
which situation?
If we do shaved ice, we can move the TA down.
No, but in which situation is 5 milliseconds what you would code it as the value you use in your
If we can
implementation?
get the ice check size down. As soon as we
I
do
see.
if we're successful with shaved ice, we can, that's the only thing blocking us from moving the TA down.
I understand now. I get your point.
Yeah, so just one thing to remind on the TA discussions. Probably with this TA that we end up having in ISPs, we're going to have to live with quite some time. So I think the discussion what we had in Buenos Aires, that we do have the separate recommended and the minimum. It made a lot of sense, but we have to make clear in the draft that, okay, this is the implications of it. So that, for example, the minimum TA doesn't end up being used always.
It may be at this point that we shouldn't specify a min at all. We should just point out that if you set this lower than what the bitrate limit is, you have a really bad experience.
Yeah.
Right.
I think that's probably wise in this case. Simply, Martin Thompson, I apologize for being that. The 5 milliseconds is basically not going to work, period, based on the numbers that you have here. It may be that we can shave the size down to the point that it can work, but I'm not actually sure that's, yeah. It just doesn't
It takes,
work.
with
It takes a lot
shave,
of
that would be
shaving.
like 220 with the best shaved you could do.
Yeah, you'd be like with the IP header, and that's it basically based on your calculations here. With this number, no, there's certain things that you have to put in that packet that take up a certain amount of space. That's sort of
And note
there is a
that-
hard
that
floor. on-
whatever
on
we
these
put in
things.
this biz draft, when shaved is published, it can update whatever number's in here, right? And that's,
Yeah, that's the other point as well. Does anyone want a bike shed on the number, or are we just going to do that on the list? This seems this is reasonable. Oh, by the way, the reason that Firefox has a much lower number actually, and we may be suffering as a result of that. The reason that you notice that we don't limit that is a regression that was introduced. We do actually have a limit.
right.
So first we need to decide if we are going to have a number, and then we would bike shed the number.
So I mean, my opinion of it, and like I'm not hung up on this, is just that I don't understand how the transport people would decide this protocol was congestion safe without a number.
Yes.
That's my concern.
Jump on it. 'Cause I mean, I think given that this is almost certainly going to be an exciting issue with the transport people, no matter what we do when this comes up, we might want to get them in the loop now rather than waiting until IESG review.
Definitely. I sent an email to the transport area working group, which got exactly 0 responses last time I looked. But we may need to go actually talk to some people.
Yeah, could, buttonhole somebody. The other question I had is that you mentioned something that we mentioned sort of offline. I just wanted to raise. You said, when you have a bandwidth limit, does that imply, you seem to imply that implies, drop if exceeded as opposed to leaky bucket. And I wanted to see do you have a strong justification for that, or?
So if you tried, so here's what I've simulated. Here's what I know from simulations. If you just totally queue it, you say, I'm going to, we got infinite memory on all these devices. I'm going to queue up every stun check you're ever going to send and just send them at, whatever the bit rate is. It really doesn't work. They get queued and smeared way out, and there's no way the suicide packets will work. So could you queue a little bit with a leaky bucket? Maybe. I didn't play with that, but you certainly can't have an infinitely deep queue. That I'm convinced of, having done a few simulations. How deep it can be, I don't know.
Bernardo Bobo, Microsoft. So I think there are two very distinct issues here. One is the DDoS protection, and the other is the whole transport thing, which would really, there'd be no number that would come out of that just purely for transport. But what they would ask is some kind of a congestion avoidance or back off that would occur.
We
So-
don't have one, and we can't have one.
Well, but we do, right? There's retransmission and back off in ICE.
Oh, sure, I understand that, but the issue is, in most of our ICE transactions, we never get a response. So
Yeah.
yes, we back off, but we still use up a certain amount of bandwidth.
Yeah, so I'm just saying they're two different things, right? There's the DDoS protection, which is why you have the global limit. And then there's the transport behavior, which is somewhat different.
Okay, and on the topic of getting transport folks involved, yes, indeed, we did. I also sent an email like a year ago to the transport area, and then we also had 2 meetings ago, we had a bunch of transport guys invited there, and we do have Martin Simmering, our transport expert, and also about a month ago, I dropped an email to the transport ADs and our transport expert, checking, okay, these are the numbers we're currently discussing. What do you think? So far, no one cried in terror.
Did anyone say it looked fine? Did anyone reply?
There was a very short discussion. We may need to
So look,
ping again on
here's a
that.
really pragmatic thing to do. Ben, can you help us round up a few transporty folks and and with whatever the chairs and figure out we can get some advice this week here as some preliminary thing? That'd be really awesome. I would, a lunch or something.
Like here tomorrow.
Like today, I guess. Yeah.
Sounds like a coffee break.
My
between
breakfasts are
sessions.
free.
Varun Singh. So I'm trying to wrap my head around this, and it seems that if you set so when you think the 250 kilobits per second would be a bad value, because if there's only one ICE agent doing the pacing, presumably you have a good enough TA there that you don't hit this number, right?
With a TA of 5, so yeah, you're going to want to set your number such that you never hit the limit, whatever the limit is.
Right.
That would be a bad thing.
Like
right?
if you have one ICE agent.
If you have one ICE agent and and let's say the number was 250, clearly
You want to use the TA
you
of
want to
20.
use 25 roughly, it'll work.
30,
Maybe
right.
something a little
Yeah,
more
so
than that.
because what I'm trying to understand is the interaction between the global limit and the individual TAs that implementation might choose. So for example, you come up with multiple peer connections, right? And the problem would be that you choose the wrong TA and you hit the 250 kilobits per second. And then you want to like specify the interaction of the algorithm when that happens. What you're saying is that you don't do anything. You basically like queue your packets and the packets will be dropped. And then perhaps the agent would look at the drop packets and say, oh, blimey, I chose wrongly, or maybe I should change my TA, or what do you think would happen at that point? Because
I'm suggesting we don't need to specify that. What we need to do is warn people that if you don't have, if you do 2 PCs that each use 200, you will really hate life. That'll be bad. And that you should do something to stop that from happening, either with a really clever implementation that can automatically figure out how to set TAs for you based on knowing how many peer connections there are, or just as an application developer dealing with it yourself, either by manually setting your TAs to values that will work, or by making sure that you do your peer connections sequentially instead of in parallel.
right, and I think the guidance there needs to be very accurate, because the way I understand it, like leaving it like in the open, I have a feeling that people may not do anything, and people would just keep hitting the same error situation again and again. And that would be very frustrating, both as an application developer and a network operator, because you then know that there's something broken, but there's no way of tweaking it.
Right. So here's the thing that really scares me about the whole story you're doing. My JavaScript for my app, I can maybe get that right. If I'm probably most JavaScript programs get anything right, but let's assume I got that right. Okay. And we need to put good advice on this in the WebRTC specs and stuff. But my app works fine most of the time when I'm running it. But in another tab, there's Facebook running an advertisement that's also doing peer connections. We're already seeing plenty of peer connections coming up in really random places. And it's another tab. There's no way I can possibly know that it's even there or running.
Right.
Now, the browser could do something clever here. It knows about all of them.
Yeah, but I
can't.
guess the definition of the application that you did not specify, it's kind of vague on, it's a single tab, multiple iframes within a tab. I understand that, right? The fact is that you cannot control or police anything. But the thing is that as soon as you hit the 250 kilobits per second, everything's going to see like a behavior, and they don't know why this is happening. As it is it self-caused or is it caused by something else? And there might be something that's not listening, right? So there might be your app which does the tuning, but then the other app sees more and then exploits that.
You're totally right. There's a lineup behind you.
I was actually going to make the multiple tabs point and go a little bit further and say that there's nothing really the browser can do to be that smart to handle all of these, other than, you know what, I'll do my pacing in order to have 2 slots to allow for 2 agents, but then what happens if you add the 3rd agent? The only thing you can actually do is...
Let me propose something that might change your mind.
Yeah.
What if I allocated half the bandwidth to the first PC, quarter of the bandwidth to the second PC, an eighth of the like I keep binary dividing the remaining bandwidth. So
Right.
that I.
So that means that you have to know that when you're the second PC, you really are the second.
But the
there could
browser
be-
knows that. The browser
What-
knows exactly how many ICE agents it's running. No problem. I'm not suggesting it's a good idea. What I'm suggesting is this is purely a thought experiment that proves there might be an algorithm that would work.
It could, but another thing that we might want to do, and I'll state in a second why I'm saying that, is that we can also decide to delay the entire peer connection a little bit. If we are doing that, however, that would need to be something synchronized with the remote end and say, wait, this entire thing is being delayed a little bit, which would imply some amount of signaling, which would imply work for us to do here as well. So we need to have our story straight before of whether we're going to do this half splitting all the time, or whether we're going to do some signaling based approach before we decide where to go.
I like this new Google app where you see the video, but it starts ringing, like, no delay. It's awesome.
Yeah, and a Reddit forum that says just stop using 50 tabs at the same time.
Okay, so I'd like it if we could not design WebRTC's solution to this right now, and just like go along with the idea that other different usages are going to have to figure out what they're going to do. Because, for example, Clue or whatever other thing Linux works on is going to come up with something else that has nothing to do with browsers and tabs and JavaScript and Facebook and whatever. So, I'd like to get back on the topic of the bitrate thing. So, given that, well, Chrome did 256 kilobit. What was yours? 128?
You're at enough to take down many websites. No,
Yeah,
sorry.
250 is a lot. So, I mean, I ran the numbers on this, 2.5 years ago when I first sort of discovered this problem. And in Firefox, we actually have a limited 128 kilobits in any given second. We actually have a second limit that is less than half that over a 20-second period. And if you do the number, if you run the numbers on ICE, you sort of see that there's this possibility that there's a spike that happens shortly after the retransmissions start kicking in. And then it's sort of, there's this long tail. And we were concerned that if you had multiple ICE agents sort of started up and running continuously, the continuous output of those things could be a problem, as well as just spikes. And so I don't know if we want to do that.
I should have been clear that that 480 kilobits per second was computed over 100 millisecond windows. So like this, and this is one of the questions I said, the transport areas. What's the right way to compute this stuff and whatever? But
it's really challenging.
It's challenging. Yeah.
We need to not only pick a number, but we need to pick a number in a window over which that number is going to be enforced. To the point earlier, when you lose these packets, we're going to need to know that we lost them. And there's a very simple modification to stats that I think will ultimately work for WebRTC.
So you're at 128. The limiting factor for all intents and purposes right now for you would be the 128 in the 1 second. Probably not the half in the longer one.
Well, it's less than half, but it's
okay.
Yeah, some other number. It's like 7.2 kilobytes per second, which is.
No, that would be the limiting
like 50,
factor.
Yeah, it is a limiting factor.
I see.
Yeah. I mean, you have to have several agents in order to trip that, but yeah.
Peter Thatcher. Just one other data point is that we've set our TA in Chrome, or we're currently setting our TA in Chrome such that we won't go with the current packet size with one peer connection. We won't go above 64 kilobit. So that's kind of our.
Well, I mean, from a DOS point of view, right now, Chrome goes almost to a megabit.
Well, it's not supposed
multiple
to. It's supposed to be.
Yeah.
Even with multiple, it's supposed to be 256. So.
Okay, that's just a bug. Then we'll
Yeah.
ignore that little detail. That's, yeah.
So I guess that's the ballpark we're at. We're like 64 to 256, somewhere in there, I guess.
I cannot imagine that this discussion will land at a number outside of that range. That's like seems highly likely to me. And I actually want the biggest number possible.
Okay, so speaking of numbers, I've been a lot of discussion on that, and yeah, I would like to say, yeah, let's take it on the list and keep on bashing, but no, we cannot do it anymore. We've been doing it far too long already. We need to agree on a set of numbers we feel comfortable going forward, take the discussion with the transport guys, and really still aiming for the last call next month. So that would mean in the next week or so having the discussion, or preferably today.
Okay, so let me give a really concrete proposal here and see if everyone can buy into this. Okay, we add a. Let me get to my proposal. This one is doing like that's happening. It has nothing. We don't modify the draft. It's just independent of this draft. This one again is a different draft. It's happening.
Take the mic.
Sorry. So the bottom two bullet points on that slide are like other issues and they're happening. Done deal. Okay. The concurrent, the not specifying the details of what happens when you go over the rate limit, it seems like we're probably okay with that in this spec, and maybe in other specs we do it, but we write some warning text that explains what happens. So the real proposals of changes to the ICE-Biz draft that we're trying to get to working group last call, I propose that we add a global rate limit of 250 kilobits per second. I'm not saying we'll get that number, but I'll say, let's take the highest number possible to the transport areas and see what they beat us down to, okay? And when we can argue the number later, but we put it in like that, written that way so it's concrete. At the same time, we actually remove these min and recommended about the TA and just replace it with text that says like, look, you can't exceed whatever your bit rate is and don't, figure it out. There's no specified min or recommended, and that we negotiate it.
Yeah, so Martin Thompson, I have a slightly different proposal. I like the fact that we have a way currently, well, there's this kind of de facto way that we do pacing on both sides.
Yeah.
And what you're proposing, I think, loses some of that. And I would prefer to keep the SDP signal because I think that's the best way that we can settle on a TA value and get the pacing right on both sides. And simply adding an attribute to the document is not going to hurt that much. And I think what you have here is basically right. You just say, A equal ICE TA colon 50.
Yeah.
And
Yeah, so if I understand, I mean, that all is already in the specs. It exists, this negotiation mechanism for agreeing on a TA. So what Colin is now suggesting as a change is that we remove the recommendation or minimum value, what you would put in the negotiation.
So you already have the negotiation?
Yeah, the negotiation already exists.
That's new, isn't it?
No, it's been there a year. Oh yeah, it's not in the original RFC. It's in BIS and ICIP SDP.
Okay.
The BIS draft has, because it doesn't have the signaling part, it just says you need a way, and ICIP SDP defines this SDP parameter for the negotiation.
Okay. Got it.
So
You're clearly not going to have that when you're with an old endpoint, right? I mean, then you have to use the pacing that is in the original spec.
Yeah, which is well,
You just have to
just have a default value for it or something like that. Yeah.
Yeah. So, okay, go ahead.
But should we then keep a default value for the cases where,
name.
Christer, for the cases where when the remote endpoint doesn't send you a value?
Yes, we
Because
have
I don't
to.
think we want to say that go back and look into the RFC. I mean, we should have these should be backward compatible and describe, what happens. For example, similar to the regress nomination and all this stuff that can happen if the remote endpoint is, according to the RFC.
And obviously that number has to be the same as the one that is in the original RFC, or the suicide packets don't work. So it's not hard to figure out what that number is.
Okay, so what I'm hearing would be actually then remove this minimum TA text completely. That's,
I don't
I guess
care
that's-
strongly about this one way or another, but I don't think
Okay.
it serves any purpose really at this point.
So I think we have three choices. One is do nothing. One is add the bit rate. Oh, sorry, Peter Thatcher. One is do nothing. One is add the max bit rate, and one is add the max bit rate and remove the TA stuff. Right? Those are the three choices. I'm actually in favor of choice 2, but we can do.
I can live with 2, no problem. I have
I'm-
a slight preference for 3, but I don't think it really makes much difference in the end. But one I do not think will get us to an RFC.
Okay, well, I guess we can take a quick show of hands on those options. So just to make sure we get the options right, can you repeat them again?
Actually, let's factor those 2 independent things. Let's just have one question that's about adding the bit rate, and a
Yeah,
separate questions about whether we remove the min TA
Yeah, that's
or
fine.
not.
That's more clear.
Yeah.
Okay, so
All right. Should we do a hum?
we can do a show.
Show of hands. Okay. Show of hands for those who are in favor of adding the max bit rate as a global max bit rate. Those who. Oh, sorry.
10-ish, so big fraction.
Those who are opposed. For the 0. Notes for the notes 0. Okay.
Thanks.
Second question. If you are in favor of removing the TA, min, and recommended values, raise your hand now.
Yeah, we need for the legacy.
Yeah, you leave the default for the legacy.
Yeah.
But
So
you
we're really
remove the
talking
min
about
and
removing
recommended.
min, more or less. Yeah.
Okay, so wait, we saw.
Do you want to talk? Why
So-
don't you
so Martin
explain this
Thompson,
to us? Yeah.
I believe that what we have here is that there is a default in the MMusic draft that describes how you use ICE with STP. Right? That document establishes how you decide on what the TA value is. This document says you need a way of deciding what the TA is.
Krister, is this making sense to you? That the backwards compatible min should be in the SDP document, not in the IceBiz document.
This document only needs to say that both peers need to agree on a value for TA.
Yeah, wherever it is.
Yeah. Okay, does that sound reasonable?
Yep.
Currently, the pace calculation formula, Emil, I forgot my last name. Currently, the pace formula says you calculate your codec rate, the number of streams and everything. And if you happen to not know these things, use this value. Does that mean we're not going to have such a value? Is that what this hum is about?
Yeah, I think we're proposing we move to, the size, you know roughly the size of your stun messages and roughly how many peer connections you're doing at the same time. Choose TA appropriately.
Okay, so that is no longer part of IceBiz. That was removed because now we wanted to align in IceBiz. We wanted to align RTP and non-RTP. So all the calculation was removed from IceBiz. Krister, that's correct? I think we agreed to remove that in BA. No? This whole calculation of how you, based on your RTP, P time, etc., how do you calculate the TA? That's all removed. That's no longer part of IceBiz.
I no longer feel guilty about not reading this draft in the 1 week I had to read it.
So we can, of course, I think the calculation is still part of ICIP SDP. I would also have to check myself. And yes, we can have in ICIP SDP, we can have the legacy compatible parts, because anyway, you would have to do SDP in order to be compatible with legacy. That's all fine. And then the question is, what do we have in IceBiz? And it seems we need a global limit. That's what we want to have. And based on the global limit, you would calculate your TA. And then on the whatever signaling mechanism you have, you need a way to negotiate this. Sorry?
20 milliseconds is still in 5245 bits.
That's in the appendix, right? That was Is that appendix or?
No, that's 13.1.
Okay, it's a bug.
Ben Schwartz, Google. I'm just trying to understand, are we really going to tell implementations that they must respect and follow the signal TA, even when they know in advance that doing so is going to hit their hard rate limiter and result in packets being dropped? I mean, after negotiation, when you've negotiated a TA, if changes in circumstance result in your ability to predict that those packets are going to be dropped when you send them, do you still have to obey that TA, or are you permitted as the agent to back off the TA to a higher TA?
You're certainly welcome to renegotiate the TA, but I think you have to follow the TA until both sides are doing it, because both sides need to be running the same TA.
Okay.
But if they're being dropped, it doesn't matter.
Yeah, so Martin Thompson, I think there is a 20 milliseconds in 8.1. I think that's just a mistake because we have evidence to suggest that 20 milliseconds is no longer the floor and for NATs. I think we're fine. I think this is the right thing to do. So I don't know what. Maybe people are confused about what the properties of the system that we're producing here is.
Krister, it's not 8.1, it's B.1, it's an appendix, and this is actually, it's the design motivation appendix, and this is actually one part that I forgot to bring it up, but I talked with Daria and offline that this is actually something that it was copy-paste, I believe, from the RFC, and this is maybe something we should remove completely. At least this B.1, which talks about this 20 milliseconds. But I don't think you will find this 20 milliseconds anywhere else in the document. It's only mentioned in this Appendix B, which design motivation stuff. And it's not B.1? Oh, I apologize. Okay, so I need to take a second.
But I mean, I think the relevant conclusion here, like regardless of what the draft says, we want to get rid of 20. I mean, it'd be 5 or whatever, right? We decide here, right? Yeah.
Are we talking about getting rid of 20 as a value and having some other value? Emil is my name. Or not having any value at all? I'm confused. What are we removing any value from 5245 bis, specific value? Yeah.
Okay. There's two paths we could go down. We could just stay with some values for a reason, but the thing I'm asking is, why would we have a value or a limit, right? Really, I always, look, we used to have one because it was how we rate limited things from using too much bandwidth, is we use this value. We're now moving to a different value to rate limit, which is the 250, from which you can compute these things. So in the spec, let's just say that we in the spec said the minimum value was 20.
Mm-hmm.
And then somehow somebody like made magic shaved ice that really reduced the size, and some other things happened. We could figure out we could send them much faster than 20. I mean, I guess we just update the 20 at that point with those drafts. So you know what, I feel like this is a real bike shed thing here. Like maybe the simplest thing would be the least change to the draft, and we should just leave the values in there. I can live with that. I wasn't seeing what value they added. Like, what specification reason did we need to specify a min at this point in time?
So I don't have a strong opinion for this. I think that when implementers are implementing it, that they don't necessarily always have all the cards in hand, so they appreciate a default value that they can start with. I know that I used it that way at first. I'm slightly uncomfortable dropping any values now without knowing exactly what will follow, because like, yeah, let's drop the values and we'll figure it out later sort of reminds me of, yeah, let's leave the EU and we'll figure it out later. So I'd rather we know exactly what we're doing with the rest of this, and then we come back and update. I think
it's a compelling argument.
Okay, and Emil, now as in value, you mean the global rate limit or the TAs?
No, I'm fine for the global rate limit, and
okay.
I guess we need to get some feedback from transport, but that seems reasonable, and the ballpark that Peter mentioned is reasonable. It's the default pacing value, just dumping it out like that without knowing everything else is.
So Peter, you were arguing for keeping it in too, right? Was your preference to keep the TAs in?
Yeah, I'm partial to Emil's argument that like we're moving into uncharted territory and we're trying to get to working group last call in a month, and we're out of time for this topic.
I have no strong reason for removing it. Let's just go with that if that's okay with everybody. Leave it like what Emil and Peter are proposing.
Okay. But we do have the consensus to add the global bit rate.
Of course, yeah.
I don't think I actually specified the number when I asked for consensus on that today. I don't think so.
No, I mean, we can, let's
Okay.
do that in a second. Let's hit any other issues.
Okay,
Mike shed a number.
Jonathan, I was just going to respond to your comment that you could renegotiate the TA in the middle of connectivity checking. That strikes me as unlikely because you can't know when your peer got the new TA value so that you should switch. So, I mean, I could certainly,
There'd be some skew. There's always, look, let's just talk about the normal, you both
No.
agree on the same TA.
Mm.
You don't really know when the other guy, you got the candidates out of
Right,
match on
yeah.
RTT skew. So we already have that. And we know that the windows in the NAS, because they're made to handle a round trip traffic, they're wide enough to handle that type of skew.
Okay.
So
know.
look, I have no idea how you can ever renegotiate anything with ICE. So I'm not claiming it's really possible to do that. But in some theoretical world, I could imagine you could do that.
Okay.
Okay, so we need to move on to the next topic of trickle ice. Just last thing, if we don't have consensus on a number, that's fine. No, it's not fine. Okay, never mind. We need a number to take to the transport guys. Is everybody happy with 256 kilobit? Yeah.
I have a
Does
feeling
anyone
they're going
object?
to feel that they know better than us about what the number should be.
Because we agreed, so.
Because we're hoping, how did Colin put it?
No, so let me, how I would argue with that with them is how we chose that number is if you go back and look at, where was the right one?
Yeah, I think you have
The-
180.
The 180, whatever. But I mean, if you look, that when we want a couple peer connections to be able to work at the same time with a small number of candidates. We want our setups to be pretty fast. This was like a number that was already lower than what we would want for our applications to set up optimally. I mean, honestly, like there's some number we would just like, we wouldn't use over 5 megabits. It just wouldn't improve our applications. But moving this from 250 to 1 megabit would make our call setups be faster in human time. So I would take to them the argument, this gives us a reasonable user experience. And as you make that number worse for us, it degrades our user experience. And that's why we chose that number. I'm not sure that's true, but that's the argument I'd make.
We have a lower bound for this already because you know what the IP is.
Krister, would you be willing to provide some text? I mean, we could put that into this design consideration appendix, which we need to update or delete anyway. But I think it would be good to have if you can put together some text, and we find a way. We put it in the RFC, or we send it to the transport guys. But that's so we have something that we could look at.
Whatever you can extract from me this week, I'll try and do. But if it doesn't happen this week, it's unlikely to happen until the end of August.
Okay, but my second question, no, what was the outcome regarding the min and default value, TA?
We're not changing it. We're leaving it as is.
As it is with the same values,
Right, we're just leaving that part of the current text the same. We're not modifying the text.
5 and 50, okay, good.
The two numbers that neither of the browser uses.
No, we enforced.
Mosinati, on the actual number for the global limit, if all these pairs end up actually being on the same network, I think it's good to have them the global limit roughly correspond to what the actual media that starts off. And a lot of WebRTC implementations are starting off like around 250 to 300. So I think having some kind of limit that sort of matches what the media that's actually going to start pumping right after all this stun traffic makes sense.
And my response to that is data channels.
I make that argument in the draft, yeah.
I'm actually talking to a separate issue about this, so if you have a comment, it's okay.
Yeah. So Martin Thompson, I think we should just put the document that we can get the text that we can get consensus on in the document without necessarily waiting for the transport conversation to conclude, because the numbers are easy to change once we.
Oh yeah, for sure. We should put this in. We just should put. I don't care if we put X, but I'm proposing we write 250 or something in the document, or any other number somebody wants if they got a better one.
Bigger
We
number.
just write something in the document so that people can do calculations based on it.
So point of reference, we're looking for things here that we're looking for other examples of uncongestion controlled transmission of data, right?
Good luck with finding anything this high.
I do have something that is much higher than this. If you connect to a website using HTTP 1.1, your browser will establish 6 connections to that site. Same IP address, everything, right? If you make 6 requests, the responses that come back with IW10 almost hit a megabit. Almost.
They come back over TCP, right?
Over TCP.
Which is congestion controlled.
Not in that
Not in that case?
not in that flight. Because it's IW10. They haven't had round trips. So that's much more than we're asking for.
Write it up, man. We're going to need whatever we can get.
Yeah.
Okay, great. I guess we have a note taker. We got all the consensus on the numbers so far, and as we said, we are going to be going for working group last call, AMIS, next month once we get all the updates that we now discussed in the draft, new version out, and we'll be needing volunteers to review. And yes, everyone, this is your chance. Who would be willing to review the document when we start the working group last call?
Oh, I suppose.
Please raise your hand. Okay. Yeah, Jonathan,
You kidding me?
Yeah. Because yes, we will be stuck with this, and whole RTC web will be stuck with this unless we get people to actually read the whole thing. You can also volunteer your colleagues. So yes, we do need definitely volunteers to read the whole thing. Emil?
Yeah, my not next year.
Okay. Nice try.
Yeah.
Nice try.
So I have a probably annoying question about IceBIS, which is that StunBIS is just about to go to working group last call.
Actually, I haven't been following StunBIS work. How much is it completely backward compatible with?
Well, they've added, in particular, they've added a new mechanism so you do the optionally, and this is supposed to be negotiated in the using protocol. You can do the hashes with SHA-256 rather than SHA-1.
Okay.
I think there'd be a lot of, and
I can tell you right now, we need that. We're going to have to reference that.
Okay.
yeah. So
And-
I think that, and there's like things where you say you can negotiate, yes, I'm doing this, and then I think that's the biggest change that's relevant for ICE. There's a bunch of stuff that's relevant for Turn, but that's not
Okay.
interesting here. But so yeah, so I mean, we're going to need, and in particular, then you can say like, okay, I don't actually want the full SHA-256 hash. I'm going to truncate it because you don't need that much entropy, and you don't want to use that many bits, which obviously you will have for ICE. So I think we're going to need to look at that and figure out.
Okay. And does StunBIS obsolete stun?
Yes.
Yes.
Okay. Well, then it's obvious. We need to.
Whatever.
Fair. Marc Petit-Guenin, so co-author, co-editor of StunBIS. Whatever. I probably cannot do a full review of IceBIS, but I can do a review of IceBIS related to StunBIS.
Okay.
If it
Thanks.
will help.
Okay. And if you have new names in mind who would be willing and able, or at least willing to be review the IceBIS, yes, please let us know. We will definitely need people to many eyes on that document.
So when we get closer and know the actual timing, I will try and figure out time. But it may be, August is traditionally a pretty difficult time to get a lot of good review.
Okay. And likely it's going to be more than 2 weeks of last call anyway. So
Fair enough.
great. Thanks.
You can also send me.
Sorry.
You can also sign me up.
Yes, thank you, Emil. You have the clicker? Oh, there.
Yeah. We didn't talk about running ISO real quick so that we get congestion control for free. That might be food for thought. That was a joke in case it wasn't clear. Thanks for laughing. So we've closed a bunch of issues in TrickWise. I'm going to state right up front, there are no more open issues. It's an immaculate document, obviously the most perfect document ever written. I'm sorry? Yeah, right. So I'm going to go through them, through the closed issues since last time. Now, the first one was, Peter said at one point, hey, when we're doing nice restarts, it might be that we have something in progress. We do a restart, but we don't want to close the current processing, so we'll be getting candidates trickled simultaneously from the two generations of ICE. So we need to add something like this at the end to say this is a candidate that belongs to this generation. We talked a lot about it, decided that this is something that is entirely specific to the usage of TrickWise, because sometimes it would be text, as in here, as part of SDP, and sometimes it would actually be part of a JavaScript object or with some other programming object. So this is what we settled for. We say that there has to be some indication as to the UFrag that this candidate belongs to, and we added an example for how you could possibly do that with TrickWise. For the record, TrickWise for SIP already adds that in the SIP info messages. Yeah.
On the next, I mean, maybe this is again an issue that ICE itself needs to say. It's not. I think just saying which, are we calling it generation, it applies to is not sufficient. You also need to know, and I think maybe ICE needs to specify this, and you know, and TrickWise for SDP need to fix this. That if you do an ICE, that you need to know which generation on each peer is paired up with each other. SDP offer answer gets that for free because it's offer answer. Jingle, this is broken. And we want to make sure that, you know, other things aren't broken also. Because if you get generations paired up wrong, you just completely fail.
I'm not sure I understand the concern. So just to be clear, we're not talking about generations the old way it was specified with TrickWise for Jingle. I just was using that term maybe in a easy way. We're just adding UFrags.
Yeah, no, I understand. But basically, so I do an ICE restart.
Yeah.
And then I do another ICE restart immediately. And then I get a response from you with you know, I send.
Oh, right.
You know, UFrag B, and then I send UFrag C, and you send me back UFrag D. I don't know whether you're pairing with B or C. Except, I mean, SDP offer answer obviously tells you that.
So you're saying that we basically need to say that the signaling protocol should resolve this.
Yes. But that's up to the signaling protocol.
Yeah.
That's true, but I mean, we need to say somewhere that the signaling protocol
Needs to resolve that it needs to figure out which candidates pair with which candidates.
Yes.
I mean, that's kind of like remember to eat breakfast. I don't know. It's so obvious.
Apparently, Jingle didn't remember to eat breakfast.
Okay, well,
And I think
that's kind of it.
For SDP, I'm not sure remember to eat breakfast either.
All right. I guess I'm not opposed to to putting something in there that says, you know, do smart things. But
So for the notes, can we have an action item to?
Maybe that's for MBs. I don't know. But I guess this is.
Jonathan, Mike.
I mean, obviously, what typically you do is for MMusic, but I think both, probably IceBIS and Trickle need to say.
You need to have that covered.
Yes.
Is what I was going to say.
Yep.
Damn you. Okay, I thought we were done with that.
Yeah.
Okay, so this is the one that we already discussed. That basically says in the table that we discussed before, in the unfreezing table, when you start unfreezing your pairs, you start by the topmost in every component, except that it says it with media streams and components and everything. I'll leave you a moment to read that text and see if anyone has objections to it.
It's more clear with the table.
Yeah, I agree with that. But since we were going to have the example in 5245 bis. I was hoping that we can piggyback on that.
Jonathan, and again, this also means that, like we said for ISPIS proper, there needs to be a well-defined order among all the.
Yeah, I've already taken an action
Okay.
item for that.
Okay.
Yeah, we have to.
Is the signaling protocol responsibility?
There's already text that says when we talk about order. Actually, here it is. The first media stream that was reported to the ICE implementation from the using application. Maybe that's not clear enough. I'll make this an entire paragraph.
And Jonathan, like I said, I think it's the signaling protocol's responsibility to define what first means.
Yeah, when we talk about signaling protocol, I'm a little bit confused in the WebRTC case. Do we also mean the SDP that comes out of the browser?
Yeah, well, in WebRTC, it's JSON.
Okay. Yeah, or I have an action item for that. So finally, there was this decision in IETF 985 that was saying, imagine that you receive tree code candidates. When you receive a tree code candidate, you go through your current checklist, and it turns out that you already have candidate pairs that match the candidate that you just received. The reason you would have those, the most common reason why you would have those, is because they already popped up as peer reflexive candidates. So originally the idea was to say, you know what, just keep the higher priority one, and everything should be fine. Now, the reason you actually care about this, and this was summarized by Taylor, actually. So he made a very good point that the reason you care about this is that you want, at the end of ICE processing, you want the two agents to have the exact same opinion about what the priority of every candidate pair is. And the reason that matters specifically is for aggressive nomination, which we still have to support, right? Even when we're removing 5245 bis, I think, right? So in aggressive nomination, the race condition at the end where you've received used candidates for multiple pairs, you're supposed to use the one with the highest priority. Yes, Christian.
Chris, yes, true. We support aggressive nomination for backward compatible,
Yeah.
but do we expect an RFC compliant endpoint to do trickle?
Huh?
Isn't that sorry? Maybe I misunderstood what you said. I mean, we do need to support a case where the remote endpoint supports.
Are you saying that no trickle ICE implementations would ever do aggressive nomination?
I'm not saying. I'm asking. I thought that if you do trickle, you have to support BIS, but maybe I'm wrong.
We can certainly stipulate that, but given that currently all existing trickle ICE implementations actually do aggressive nomination as per 5245 old,
okay.
then we should probably have that case covered. So anyway, the solution is pretty simple. I'm just trying to explain the complicated reasoning of why we got here. So again, the bottom line is you want to have the same vision on both sides about what the priorities of each pair were, which means that if I have a server reflexive candidate that I sent to you as a server reflexive candidate, but before I trickled it to you, you already discovered it because I was doing checks and it popped up as a peer reflexive, your priority would be the one associated with the peer reflexive candidate, which is higher than the one that I would have with the server reflexive one. So if I have another pair that's where the priority is sort of mixed up in between the two, we would end up thinking that the selected pair is different. So it all boils down to this, where we say, you never, so every time you have such a duplication that is a pair that you just formed because of a trickle candidate matches a pair that already exists that you had because of a pure reflexive candidate, you would keep the one with the highest priority, unless in the case where the one you already have is pure reflexive, in which case you would always replace it regardless of the priority. This is what we got to, and it seemed to have consensus on the mailing list. Jonathan, you actually said that you were okay with this. So
Yeah,
please
I mean,
don't.
I like the concept. I'm just going to have a wording tweak, which is that I think technically it's possible to signal a candidate as peer reflexive. I don't think you want that to apply. I think this specifically applies to discovered candidates that you discovered through the actual, because those are definitely special anyway. Those are those ones you don't pair up with everything else. You just pair up with the one it was discovered on. So those special things, when they become general, get the signaled. Basically, something that you discovered through connectivity checking gets replaced by something that you discovered through signaling. Even if somebody puts PRFLX in the trickled candidate, then that's not special. It's only if it's actually that you discovered it because you received an incoming connectivity check that it's special.
But then
I think there's a term for that.
Then if you did that, then you know about that candidate, then you wouldn't be trickling a stun candidate, a server reflexive candidate with the same address after that.
No. I'm talking about. So I mean, that's true. So I mean, it's very unlikely that somebody would trickle a PRFLX and then trickle an SRFLX, though they might if they're confused or something. But
so you're saying apply that text only if the candidates are true peer reflexive candidates and
not trickled
imposters.
not trickled as perflux.
I mean, does it really matter? We're just trying to make it so both sides have the same priority. So as long as the rules applied on both sides.
Yeah.
Actually, yeah, that's true, because if you signaled it as a peer reflexive candidate, then you know about its priority and its existence, so you would still have the same view of their priority. And the whole conflict about aggressive nomination doesn't apply anymore. Jonathan said probably so.
Tim Panton, just for clarity for me and hopefully nobody else, what does replacing actually mean?
That's a great question. It means nothing except for in your current checklist, you basically update the priority field to match the one of the new candidates. And at the end of ICE processing, when you're making the choice of which candidate pair won the race, you base your choice based on that priority. We're not throwing anything away. We're not even restarting checks.
I mean, I believe, Jonathan, I believe that if the checks are still in waiting or I guess frozen state, then it changes the order of the checklist. Changes which one will come out of waiting first.
We don't say that.
But I think it says that you pull things off the checklist in priority, or you take the highest priority check off the waiting list. So
I think you're right.
So I mean, that's just kind of an implementation thing that, it's the priority at the time you pull things off from waiting into in progress, not
all right. So
the initial thing when you form the checklist.
Mark, for the notes, can we have an action item clarify what replacing means, what replacing candidate pair means? And so, Jonathan, you're basically saying it's okay to specify it as we remove and re-add it, basically, unless we're already doing checks or unless checks have already completed, in which case we don't do anything.
Well, you still change. I mean, if checks are already in progress, it still has the effect, obviously, of changing which ones wins the aggressive.
Sure.
Nomination.
So yeah, in that case, we only update the priority.
Right. Yeah.
But in the case where it's still in waiting, and actually maybe not even in waiting before that, then we remove it from the checklist and we re-add it.
I'd say that you restart the checklist is how I'd put it, but however you want to.
Oh, that would be.
You move where it is in the checklist.
Yeah, which basically means taking it out and resorting it, basically reordering it.
I mean, it's all. I mean.
Yeah,
probably how you think of it depends on how your
point.
implementation is implemented. Ours is a linked list, so you're moving it.
You mean they move by themselves? You just change the priority?
No, I have to do it.
Yeah, right. So you remove and re-add. Yeah. Okay. So I don't know how we ended up with more action items than we had previous time right now. But is there anything else that anyone has as a problem with trickle ice? Because there are no more open. I'm sorry.
We need reviewers.
I'm sure you want. It's such a well-written document.
Kirsty, just one question now, and we talked about this a little offline. I don't know about this base trickle document, but the trickle ice, SDP ice, whatever it's called, makes the assumptions that you're always going to add candidates. You're never going to remove those. But now there is a suggestion. This was from Peter. Or
We can come to that when we
no,
come
no.
to
But my question is, if we move forward with that, or I mean, if there's going to be a case where we are actually going to be able to remove candidate explicitly, are there some assumptions in trickle that are not really true anymore that we would need to somehow modify? No.
No, I don't think there's any problem at all.
I think Krister means things like saying, now that you're adding stuff, you pair it with everything, and you probably have to say, unless things that have been removed, or something like that.
I don't think there needs to be anything in the trickle doc to force to preempt a possible thing we write later.
Kirsten, I mean, the way I commented, but this wasn't the ICE SIP SDP draft, was my question was when you send this new info and you have these candidates, if there's for some reason a candidate, I mean, you're supposed to send the new ones and all the old ones, and if there for some reason is missing one candidate, does that mean that it has been removed? And reply was, no, you can't remove candidates. So even if it's not in this new message, you still assume that it's there. But now, obviously, if you're going to have a mechanism where we can remove a candidate, then if you receive this and something is missing, you cannot just assume it's still there, but you have to know maybe it's been removed.
I think we can try and take care of that one if we get that far. First, we would have to decide we actually want to do removal, and then we'd have to decide on the mechanism for it, and that's far down the road.
Okay. So if there isn't anything else, I'm done. Thank you very much for the feedback.
Yeah. So same question for trickle ice. We'll be going for last calls pretty soon because all these issues seem pretty fast to clear. There is no more open issues. So we need volunteers to review. So when we do a last call, who would be volunteering to review trickle ice? Okay. Okay, Tim. Anyone else? Okay, we're gonna need more than one reviewer. So of course, we'll be asking on the list that if you know people who care about these mechanisms, like in RTC web context, for example, please make sure we get people to read this. Otherwise, it won't be going forward. Okay.
If you remind the RTC web chairs, we will ask for reviewers.
Okay. Can you consider RTC web chairs reminded now? Okay. We'll drop them an email. Thanks. Okay. So I guess nothing more on our working group documents. We have still 20 minutes for our potential new work on the ICE group.
Okay, somehow we actually ended up ahead of time. So I have 7 more minutes than I expected. So I'm going to be covering 3 drafts really quickly, all related to mobility. And at the end, my big question will be, how much incremental improvement do we want to standardize in this working group for ICE? Do we want to do any of these 3 things, all these 3 things, just one, none, or something else? So I'm going to go quickly through all 3 of them, and then we can take questions and comment at the end about which ones we think we want to do. I don't want to get into like really deep technical, like how would this work? We should first decide if we want to work on it at all. So in context, the TRAM working group is proposing the standard for turn mobility. So they're already working on situations where you have more than one network interface and you can switch between them. So the idea here is to do something similar for ICE. We could say that we only use turn candidates and we use turn mobility and then we're done. That would accomplish just about every use case as far as mobile goes and switching between Wi-Fi and cell, but obviously we would be using turn all the time, which is suboptimal. So anyway, here are the goals that I and my coworkers at Google have been trying to achieve. with the 3 drafts that we've written and implemented. First is that we want to prefer Wi-Fi or cheaper network interfaces over more expensive ones like cellular. We would like to be able to switch back and forth over time as the network interfaces come and go, and work or don't work. We want to minimize the disruption when doing that switching. And then slightly different topic, with Wi-Fi and cell and IPv4 and IPv6, you can end up with a lot of turn candidates, which turn into a lot of turn candidate pairs. So there's a mechanism for avoiding that. So like I said, the decision here is how much do we want to work on. Our general choices are A, improve ICE incrementally with perhaps these drafts that we've written. Option B is to say, hey, ICE is good enough for now, we're done, close the working group or whatever, and then start on some brand new ICE NG where we like start from scratch with trying to fix all the things that we think are important. Or we do both, where we incrementally improve ICE while we design some ICE NG. But this is basically option A, or I guess option C also.
Is the debate open, or do you have more supporting slides?
No, I want to go through all the things and then sort of cover. So incremental improvements, like I mentioned, are 3 things: network cost, renomination, candidate removal. I'll go through the details of each. The first is network cost. So network cost is basically the idea of, let's say you have 4 candidate pairs, they all work, and now you want to select which one you're going to use. And on the controlling side, nominate which one. So you want to pick the Wi-Fi, obviously, but if it doesn't work and you only have one, you would pick the cell. But the problem is on the controlling side, or even on either side when you're doing selecting and not just not nominating, you don't know what the other side has as its network interface. You don't know if it's Wi-Fi or cell. So we could signal whether it's Wi-Fi or cell, but that doesn't generalize very well, because if in 5 years we come up with a new wireless thing that is not Wi-Fi or cell, then what do we do? So we generalized it with the concept of a network cost. And also, sometimes cell is in fact marginally free. You know, if you have an unlimited data plan, then maybe you mark it as free, just the same as Wi-Fi, and you would maybe pick Wi-Fi cell if it has a lower RTT or something. So the solution that we've written in the draft is basically to signal on the candidate a network cost that you see on the very right here. And you also have a new stun attribute, which is the cost, which has the network cost, which is a UNT16. And the higher it is means I don't like this one, avoid it. And the lower it is, like 0, means, you know, use it freely. And that information is sent from one side to the other, and then you have the information about both sides, and you can make the decision of which all of the things considered equal, you would have the information you need to pick that. There's also this idea of network ID, which is useful in certain contexts. You can read the draft if you want more details on that, but the primary thing here is the network cost. Now you might say, why not candidate priority? And we can get into the details if you really want, but basically there are a couple reasons why having a separate attribute is nice to have other than candidate priority. Okay, next, renomination. No, I want to go through all of them, and then at the very end we can talk about which ones we think are the most important to work on, or none, if everyone says no to the whole thing. Okay, so renomination. The problem we're trying to solve is that aggressive nomination is gone. We only have regular nomination, which means you can only nominate once. Now that gives you, it leaves you without a lot of flexibility. So for example, if you want to do something fancy, like have a backup candidate pair, so that when your selected candidate pair fails, say it's Wi-Fi and your Wi-Fi goes away, and you want to have a backup candidate pair ready to go, you can't do that, because when you switch over, you can select it obviously, but you can't nominate it, and so then you can't have convergence on the same candidate pair, unless only one candidate pair happens to work, and then you hopefully, you know, both end up selecting that one. But it's nice to be able to nominate it. Similarly, if you are trying to do something fancy like a never-ending gathering, a never-ending trickle, where you add candidates as they come on with new Wi-Fi or whatever, you can't nominate any new candidate pairs that are created from those candidates, because you nominated once and now you're done. So, and then there's another issue that's not related to anything fancy, which is basically if we're in this new passive-aggressive world, you have to decide when you're going to nominate. If you nominate too soon, then you can get stuck with a worse candidate pair. If you say, I'm going to wait until I get end of candidates on both sides, then you could end up waiting a long time, because end of candidates might come really late, or it might never come, and then you maybe set a timeout, and you know you're not converging for a while. So it's nice to be able to nominate more than once to avoid this issue. So the solution is pretty simple. basically you can imagine it as putting a value, call it X, on use candidate, but to avoid problems with backwards compatibility, just make a new stun attribute, let's call it nominate. And you put, every time the controlling side nominates, it basically increments the value. And then on the controlled side, it just picks whatever the biggest value it's gotten so far is. So this avoids problems with reordering of packets, but is basically last one wins. You can renominate anytime, last one wins. Okay, last thing is candidate removal. So the problems are, again, if you're doing something fancy, like you're never ending your gathering, then candidates just piled forever. And now what do you do? So you send a message that says, I'm no longer want you to pair with this candidate. That's the solution. There's another situation which can be kind of useful. Emil and I were debating at length on the mailing list how useful it is. So it may be, depending on your use case, may be valuable, maybe not. But with IPv4 and IPv6 and Wi-Fi and cell and multiple turn servers, you can have a lot of turn candidates. And so what we'd like to be able to do is kind of allocate them all in parallel, and then the ones that you think are worse, you send to the other side and say, hey, you know what? Actually, don't use that turn candidate. Now, this is kind of obviated by turn mobility, but turn mobility is not yet published, and it will take a while to be implemented in turn servers. So if you're in a situation where the turn server you have doesn't support turn mobility, this is a nice backup solution. So the solution in a WebRTC context is basically to have a new event that's like on candidate removed instead of on candidate, and then or on ICE candidate, and then a new one that's remove candidate instead of add candidate. So basically, anytime you want to remove one, you signal it to the other side and say, hey, this is removed. And the semantics of that are basically stop pairing with this. Not necessarily stop pinging any existing candidate pairs or using any existing candidate pairs that you've already paired with, but just don't pair anymore. Because that solves both of these problems, but doesn't introduce any difficulties that would be associated with completely ceasing the use of a candidate pair at that time. Okay, so implementation experience is that we've implemented these things. Mostly there are some fiddly details, but and we deploy them. We have a product with some users, and it seems to be working well. We don't have a lot of users, but we hopefully will soon. Yeah. So back to the big question. Now that you've seen these three things in a whirlwind, we have a few minutes and we can debate. What in general are other people in the working group interested in making ICE work well in a mobile context? And if so, which one of these three things, or all of them, or any of them, seem useful to do the work on in this working group? And of course, you can have some clarifying questions or whatever.
Varun Singh. So just going back to the network costing, and I think the example was given earlier, you could be tethering off stuff. So you could be thinking that you're on Wi-Fi, but actually you're on 3G because you're tethering 3G over Wi-Fi, right? So I'm not really sure that the network costing could be accurate in most cases.
You know, in a case where you have no information, then you have no information. But in the case where you do have information, it's worth signaling the information.
No, you would have information. The only problem is it's going to be wrong depending on how much tethering.
In that case, the default would be to go to you know the hey, this is free. I mean, really, it's distinguishing between if you have multiple network interfaces, which ones do you prefer to use?
Yeah, I suppose this comes from like some system property.
So if you only have one network interface, this doesn't matter at all.
Right, but even if you have multiple, and I might have like 3G on, but my Wi-Fi is tethering over another 3G because for whatever reason.
Yeah, in that case, we would have no way of knowing. So
my main question here is, I think that I don't know what the network cost is going to do, like how I'm going to use that. The network ID is definitely information that I would like to have, as in it would be nice to know this is Wi-Fi, and someone could say this is Wi-Fi or tethering over something else. But it would be nice to know, like without any absence of information, I would know this is Wi-Fi or 3G or whatever.
Well, just to be clear, this is not going to tell you whether it's Wi-Fi or 3G. It's going to tell you that they're distinct networks. And you're just going to have a number, 1, 2.
Right.
I think it would be kind of a privacy issue if it were.
Yeah, so like the more I think about it, I'm not convinced that where the value is. I'm not actually sure what the network cost would really imply.
So the value that we've found is that in the absence of this, you end up in cases where you use cell when Wi-Fi is available, and customers don't like that because they're wasting money.
System properties, like tell Hangouts not to use. To use the cell if Wi-Fi is available.
No, but you need you want to be able to. You still want to be able to do ICE checks over the cell in case the Wi-Fi doesn't work.
I think that the question is the assumption of how the cost is computed. Colin Jennings, sorry. Thank you, Holly. So if there was a system panel where somebody entered their costs of their various interfaces, and this would be a hideous user interface, right? It would make sense. But I mean, Wi-Fi is sometimes expensive and cellular is sometimes free. Like the assumption that the operating system can automatically generate the cost, I think is the essence of what people are poking at here.
No, it wouldn't be the operating system choosing this. It'd be the application.
Ben Schwartz, Google. I just want to clarify that Android actually does have this. This is, I mean, it can be, maybe this data can be wrong, but the operating system does have costs associated with different interfaces, and it is available through an API to applications.
It does tell you whether it's metered or not. That's true.
Yeah, just wondering if like there's a menu where you go as a user.
It assumes. I'm not claiming that the operating system's metadata here is correct. I'm saying that it does exist. The operating system claims to the application that it knows this information.
Like, just want to state that from my point of view, this seems like really fragile or brittle, because there are places where, like most of the time, my 3G is free until I land up in the US, right? Do you expect me as an end user to go and fiddle with my system properties to do this, like to make the application, as in I'm not sure if this really works,
So the question of what policy you implement is up to the application. This is just providing a mechanism for the application to signal information from one side to the other.
Bernardo Bob, Microsoft. So of the three things you listed, I think the most essential is probably renomination and removal, because interfaces will come up and down. If you have those two things plus turn mobility, I think you probably can do quick switchovers. The only questions in my mind, and we implemented basically those three things as well, and got very, very good results from them. But some of the complications we had were when you're removing, at some point you may have to do a nice restart to add things back. So that was kind of a complication when things kept going up and down. We did encounter situations where you'd need an ICE restart, and it would be good if that could be avoided. I'm not sure it can, though.
So, sorry, just clarification. You said you implemented some form of all three.
Well, we
of these?
implemented, in ORTC library, we implemented turn mobility, which actually wasn't a big problem in terms of server, because it's in one of the more popular turn servers already.
Oh, good.
So that wasn't an issue. It was very valuable because you could basically, you could start a conversation with a turn server and then go look for other stuff. And similarly, when you're moving between interfaces, you could use it as a mobility point.
Yeah.
Like you said, it's not good to use it all the time, but you could just use it for switching. But then you kind of had to have renomination to find the right thing. So that was absolutely essential to be able to renominate. And then it was a little weird because essentially you're prioritizing a turn candidate above other things. So you're kind of mucking with priority. And so you have to come to grips with that. I don't know if network cost is the right way, but you basically don't want to have to be forced to do things in priority order, or you can't really get where you
So you've implemented a form of renomination and also removal?
Correct.
Right? Okay.
And term mobility.
Okay, but
That's in ORTC.
but not network cost.
Something that's like an alternative to priority, but it's not network cost, as you described it there.
Right.
It has some of the same characteristics, though.
Okay.
Emil, Evo. So there are two questions here. Maybe just a quick comment. Like, for example, when Bernard is saying we've implemented renomination and we've implemented candidate removal, I have a strong suspicion that it is not exactly the same renomination that you're suggesting, and not exactly the same candidate. Well, as in Peter's renomination and candidate removal only apply during a limited time of ice processing. I think that yours actually work over longer periods of time, which is very different.
So no, to be clear, renomination is over the entire
Ice processing.
Yeah, it's over the entire
But
length.
once ice processing is done,
No. What we've written here for renomination, you can renominate anytime. And also the candidate removal.
okay, great.
You can,
So
you
that
can
means
remove
that you
candidates
are,
anytime.
which means that if you're renominating, that means that you're keeping allocations alive somewhere and
Or
turn
adding new
bindings.
ones. Yeah.
Or add
keep-
new ones without
either
an
keep-
ice restart?
Yeah, either keeping backup ones or adding new ones, either way.
If you're adding new ones, then you're either doing an ice restart or something that is not defined today.
Correct. Well, I mean,
So,
it's a debate whether what we call continual gathering, unended gathering is
Right.
is
And
specified or not.
this
It's like
leads us to
you,
the-
you never end trickling.
Yeah.
It's like, is that specified or not? It's kind of great.
I have my opinion in that, but I guess this leads us to the bigger question. I think the reason I'm bothered by most of these suggestions today is that they have they take a whole lot of effort in twisting the original WISE design into something that it wasn't thought to be, whereas, and that we've been delaying a nice redesign for a very long time, and it's very, very due. Like we have things like, my computer locked, but we have things like removing streams and components because we now have bundle anyway, and removing freezing and removing ice rows and keeping multiple paths as a result of a nice negotiation and removing rows of controlling controlled and all that. And with all of these ideas, there's the potential to simplify ICE a lot. And then adding any of these things that you have here would be significantly simpler, potentially. Obviously, I can only hope so because this new thing doesn't exist today. And unless we do that, then any of these additions, I feel, would inevitably result in unjustified complexity for a number of implementations.
Okay, guys, we have 3 minutes left of the session. I see 6 guys in the queue, so we're going to close the mic line, and you have half a minute each.
Okay, so Varun Singh again. So as I said, I didn't like the network cost so much, but I really love the renomination and the candidate removal, partly because as a proponent of multipath RTP, these are 2 things that I really would want for multipath to be. Yeah, sure, right, exactly. But I would like these 2 features to be available for me to do that. And if we think about getting MPRDP for WebRTC, then that would be like an essential work that needs to be done before that would be considered. So 2 points. I love these 2 ideas.
Jan Eriksson, 2 points. I definitely think we should work on mobility. But if we think forward on mobility, we have multipath, multi-homing. I mean, it's a pretty big area. We need to consider what's in this working group, or if we need to extend the charter, or what happens in other places. Coming back to the network cost, don't assume that the network interface tells you anything about the cost. Mobile interface will be on around unlicensed spectrum in the future, might be 0 cost, so don't assume anything. And it's outside the scope of this charter, but that they always know it is not enough. The application needs to know it.
As I was trying to point out earlier, like it's really up to the application to decide how to use the mechanism. But
So 2 strong points on the broad thing. Looking at the amount of the document that everyone in the room thought Colin Jennings thought said something different than it does earlier, and the fact that basically no one's been reading it, no one's been reading, I'm worried that we might run into more work when we working group last called us than we hope to find. I hope we're all done in August. That's awesome. But I don't want to see us start anything new until we have the 2 key things like really firmly out the door at ISG, not just we put them into working group last call. So I don't want us to start new work until we've done that. Now, on starting new work, I mean, this whole broader context, the mobility and all this stuff, I think that's great. I'd love to see us do it. But I think that adding hacks to the current thing is probably not the right thing to do. And what we should do is book a full day or 2-day workshop where we get a whole bunch of people to sit down and just brainstorm a bunch of ideas of how might we move ICE substantially forward to the next level of things we need. What's all the things we want? Do we add a bunch of little incremental things like this onto it and fix it? Will that work? Or do we really need to actually fundamentally restructure and clean up some of the parts of it? I'm probably in the later count. But my point is like we get 2 days and a bunch of people sit down with some ideas and really work it out versus just small incremental stuff.
So far, we have 2 people for A and 2 people for B, I think.
And I think Cullen was for figure out which of the 3 we're doing when we figured this out.
But he's workshop to try and see if we can do B.
Yes.
I would describe it as a workshop to look at A and B and decide which is a good one.
Well,
And
okay.
broadly
The-
look at it,
the last part
not
of it.
one little bullet point at a time, right? Look at all the things we might want to do versus just can we add just one more thing. That's how STP got as bad as it is.
Okay, guys. We are officially out of time in 30 seconds, so you get 10 seconds each. And yes, if we have volunteers to organize such a workshop, please contact the chairs. We'd be more than happy to facilitate one.
John Lennox, I mean, I think that solving the walk off the Wi-Fi problem is important. But my concern is that the way you're explaining this seems to imply to me you understand ICE very differently than I do, which says bad things about ICE bits. So I think that's, we need to figure out what, that first.
Mozanetti, I think you had the right 3 things, and I think you had them in the right order. And I agree with Colin that we can't do them all incrementally because I don't see how you can do renomination without understanding something about network cost. But I have concerns about any of the solutions proposed. I think we need to have more understanding of the use cases. I think we're designing just protocol for the sake of protocol. We need to understand when do you really know or when do you not know anything about the network cost? Our layer 2 is going to the same layer 3. Are you hotspotting? Real world use cases. Are you VPNing? Those real world use cases should really dominate what we do for protocol design, not just adding arbitrary, parameters and things like that.
Miguel Paris of Curento. You have proposed about select a candidate pair depending on the cost of each channel. Okay. What do you think about select a candidate pair depending on the quality of experience that could offer to the final clients? You can take into account.
Yeah. So a controlling side already has the capability of doing that. We don't need to standardize anything for a controlling agent to do that. But this, actually, the way we wrote it in making this an integer rather than an enum allows the controlling agent to balance the network cost versus the quality of the link. Whereas if it were simply an enum, you would not have that capability. So we took that into account in the design here.
Yeah, you could.
I'm sorry, we're out of time, so you have to take it offline. Thanks.
Emil, +1 to this whole global rethink Alfred, but really, I just wanted to have the last word.
Okay, thank you guys. We are now officially over time. If you haven't signed the blue sheets, please come to the front, or there's one over there in the room. And I guess we'll be seeing Sol. And regarding the workshop, if we have a volunteer to organize one, as I said, please contact the chairs. We'll be more than happy to facilitate that. We would be counting, hopefully, on someone else to actually do the hard work and organizing. Thank you.
So talking to transport, of course, everyone's in plus.
We
so I
could
can't
probably
get
do
anyone
something
online,
like that.
right? I couldn't do
Yeah,
something
later,
in front of the thing. Do you have, I can talk to a few people. Has Magnus been involved in any of this?
Magnus Festival?
Yeah.
Yeah, he was commenting on not the one.
Right.
It's our first meeting. He was there on the mic where we had a bunch of
Because he's kind of stands on the between transport and this stuff, so he might be a good person.
Yeah.
I'm going to try to go over and track down, see if I can find anyone coming out of plus.
Yes. I mean, Martin Stimmerling is our official transport.
Okay.
Tech
So we
support,
should,
whatever it is.
I sent an email. I don't know if anyone will respond in time to do anything about it. I'll add Martin to it. I forgot about that.
Okay.
I don't have high hopes for getting people together this late because the amount of spare meeting time is greatly reduced from what it used to be.
If we did get a group of people together, Friday morning works for me.
Okay.
Lunches work. Dinners aren't going to work for anyone.
Yeah.